Good evening, everybody. Welcome to week 2 of Advanced Programming with Java here at Portland State University. We continue to be 100% online, 100% remote. So thank you to everybody who's showed up for week 2 here at the beginning of class. We have 38 people. Let me tell you what we're going to cover tonight. First off, we're going to start off with some Q&A. I want to hear about how your weeks went, how you're doing with the assignments, how you're doing with the material. We're going to have some question and answers in a little section that I like to call Prime Minister's questions. So, bonus points for people that speak in a thick British accent. Then we're going to see some more coding. Last week we started seeing some test-driven development. I was writing some tests in front of you. There was a little bonus thing this weekend that a couple people showed up for. That was great. That's a recording if you want to see more about how test-driven development's done. But tonight we're going to finish off the unit tests for the student program, and then we're going to get an introduction to the integration tests, which is a different kind of automated tests that focus on the main method and validating that the main method's doing the right thing in addition to what the rest of the student class is doing. We'll do that, and then we'll talk about some things related to your projects. Yes, we're going to see the assignment 2, the second assignment in the phone bill project. But we're also going to talk about some of the requirements around testing, and we're going to talk about requirements for documenting. So we'll answer questions about like that plan of attack thing and the API documentation, and then we'll also see how to submit the projects. And so this should give you all the information that you need to complete project 1, submit it off, and get a better idea of what you're going to be graded on. And then time permitting, I hope we can take a look at some other things like building a site from Maven project, and then also talking about continuous integration with Travis. There was just a Slack. Make sure it's not someone who's just like, how do I get into the class? What's our meeting link today? Same as it was last week. Check out the pinned post in this channel. But I should be a nice person. Also, just tell them what the link is. Actually, I think I have it over here. Oops, no. I'm already here. Hope I don't mess anything up. Nice. That would be me giving my kids internet. Okay. Thanks, Alex. And the password is, actually I can just send, copy the link. There we go. Okay, awesome. So we got a lot of stuff to cover tonight. But I think it'll be good, and as always, I'll try to pace ourselves. There'll be a lot to pay attention to. There'll be a lot for me to say. I'll need to get a drink of water or whatever. So we will try our best and do all the cool things that we want to do. So more people keep arriving, and I will admit them all. So starting off though. I'd like to hear any questions that you have. So please use the raise hand feature in the Zoom meeting to ask your question, or to let me know that you have a question that you'd like to ask. Scott.
Yeah, Dave, we chatted briefly this afternoon on Slack about going over generics and apply to the phone bill class.
Yeah. So yeah, let's do that. Thanks. So let's see here. I'll get IntelliJ up. So, right, I need to open it up here. So generics. So if you go back to the early days of Java, when they have had these collection classes, and hopefully you watched the collection lecture this week, or maybe you watch the IO part, and what comes next is the collections. So the whole idea is that you have objects that contain other objects, and they sort them in different orders, and they have maps and lists and vectors and all the stacks, all that kind of good stuff. And people loved it. It was great. But one of the things that you couldn't do in the earliest versions of the Java language is specify, listen, I have an array list and I only want it to contain strings, meaning that I only want to be able to put a string into it. And if I attempt to put in something else, I want the compiler to tell me, wait, no, you can't do this. This array list just contains strings. So they added this feature to the Java language called generics, meaning that you had classes, you had methods that had what's called a parameterized type, meaning that, hey, you can say the argument to this method, this must be the method to the add method, sorry, the argument to the add method must be the same as the argument to the get method, because this array list only takes strings. Let me bring up the Javadoc, and maybe that's a good way to start with it. So let's see here. I'll look at the Java API. And so now if we look at Java IO, oops, oh, actually, I forget, wait, we have search now. So array list. Java util array list. So array list, the array list takes a parameterized type E for the type of element in that array list. And that type E is used in a number of places. So if we look at then the methods, when you go to add something, you add an object of type E. And then when you go and get the element at a particular index, it returns an object of the type E. And so what this allows you to do is to have, an array list of a certain type. So when we look at our student class, right, we saw this last week. Our array list takes an array is an array list of strings. That's your classes. And so then, like when we assign it here from the constructor, you create an array list of strings. And so now I can do things like this dot classes dot add, hello. So that works because it's a string. But if I try to say this dot classes dot add 42, 24, an integer, it says, nope, I can't do that because this array list, the add method, can only take strings. So this is really good. This helps make your code more explicit. It allows a compiler time check instead of a runtime check. It actually removes a bunch of boilerplate from your code, because previously when you went the add method, well, the add method took an object, the get method returned an object, and so when you got your object out of your collection, you then had to cast it to the type that you think it ought to be. With generics, the compiler enforces all of this. So that's a quick introduction. I got some more, but any questions about sort of generally what generics are and how they're used with collections? Nope. Okay. You might have seen that before, or just maybe it makes sense. Now, in the course, I use generics in the phone bill project. So okay. So here is actually I probably want a phone bill, which a class that isn't created by the, that's not created by the archetype. So I think, and there's a couple questions that came up about this. So yes, you need to create a new Java class called phone bill. I'd love to add it to Git. Thank you so much, IntelliJ. So a phone bill extends abstract phone bill. Abstract phone bill. And actually, okay, let me get a little bit more here on the screen. I'm going to get rid of this for the time being. So many things floating all over the place. There we go. Okay, so phone bill extends abstract phone bill, and it's saying, okay, it must implement a get customer method. But as you may have noticed, the signature, the signature OEL of the abstract phone bill class, it has a type parameter, a type parameter of T, which extends abstract phone call. So this is saying that really your abstract phone call contains a bunch, your phone bill contains a bunch of something that extends abstract phone call. And you use that T in certain places. So like when you add a phone call to the phone bill, it takes something of type T. And when you get your phone calls, it returns a collection of type T. So, and type T must extend abstract phone call. Okay. Now, if we go back to our phone bill, now we want our abstract, it is an abstract phone bill of something that extends abstract phone call. For your project, what is that? Well, it's your phone call. And so now when you ask IntelliJ, hey, would you please implement the methods that need to be implemented for me? It's saying, okay, great, yeah, get customer and add phone call and get phone calls must be implemented. And now it creates get customer, but it creates an add phone call with your phone call type, and it creates a get phone calls with a collection of your phone call type. And what this means is just like with your the array list, when you call get phone calls, you don't need to cast the objects in that collection to something else, to your phone call. It will, because you've strongly typed your collection, you get that abstract, you get to use your phone call class. The way this used to work before generics is that add phone call would take an abstract phone call and it would return a collection of abstract phone calls. And then you, the students, as you're writing it, you'd have to do all this casting and everything, and it was just ugly code. So I decided to have this also be a lesson in generic types by having a type variable in abstract phone bill. So let's see here. So yeah, Scott asks a good question. So this specifies that phone bill is a container class, just like an array list. Yes, and what it contains is a bunch of your phone bills. And because of, and it's a little awkward because you're extending my class, and so then my class, has the my class, because I don't know anything about your phone call. My class has to work on all this abstract stuff. And so it's a little different from just using a plain old collection where really you can put any old object in there. Nope, with the phone bill, it must contain something that extends an abstract phone call. In your case, your phone call class. Cool. Looks like Scott's got it. Any other discussion about this? So this is a pretty important topic and one that is different, and something that people scratch their head at the first time they see it. And maybe you've done it a little bit differently in your program. Maybe you're using abstract phone call, which you can do, but you'll have to do more casting when you use the get phone calls method. See here, something from Andrew. There's a few C++ gotchas with templates. Is there anything like that in Java with generics? There are some oddities. It's not nearly as bad as C++. There aren't the performance implications that there were, at least in C++ 20 years ago. I'm sure they fixed all that by now. There's some kind of weird and hairy stuff. And if you go and look at the signatures of some methods, I don't think there's anything that's worth highlighting right now. I think my favorites, what was it? It's in the collections class. I think it's Max or something. Javadoc collections. If you look at, I think it's the Max. Yeah, this one always gets me, right? So the max of a collection, T extends object and comparable super of T. It's like, what does that even mean? So this is why you just let IntelliJ do all of the crazy type stuff for you. And if there's no red underlines, you're good. Oh, Asher asks, what's the @ override above each function doing? That is an excellent question. Okay, so @ override is an annotation that specifies that this method overrides a method of its superclass. Now you may ask, okay, why is that important? This runtime, this override isn't accessed. This annotation isn't used at runtime. It's not used at runtime. Why do you have it? Well, it's actually used at compile time. So you have a subclass of a superclass, and let's say that the signature of the superclass's method changes. Let's say that let's say I rename the get customer method in the superclass to be something like get phone bill customer. And so as a result, if you don't update your subclass to override that same method, it doesn't override it anymore, and your overridden method won't be invoked anymore because it doesn't override another method. To put it another way, let's say there was something drastic like they renamed toString, right? You know, you've written all of your your objects to assume that the toString method is what's invoked. If they went and changed the name of it, it wouldn't override it anymore, and your toString method wouldn't be invoked in the places that you'd expect, because they would have changed all the calls to the superclass. Did that make sense? Let's see here. Is it a keyword or just a note to the programmer or a viewer to let them know it's being overridden? It's not a keyword. It's not part of the language. It's an annotation, which is a way of adding extra stuff to your code without changing the language. So what it is, it's an annotation that's part of the standard Java API, part of the language API, the Java lang package. And it is used by the compiler at compile time. If you, well, I mean, so if I have a declaration of a method that that doesn't override something, IntelliJ tells me about it. It's like, wait a second, you're not overriding a method. You thought you were overriding a method, but you aren't any longer. And so that is a cue to the programmer, the person writing the code, that, you know, this doesn't mean what you think it means. And that's actually something that's very valuable. I've done it myself, where it's like, oh yeah, I renamed something and I didn't quite get it right, or whatever, or like I inadvertently override a method where I didn't know I was doing it. So I found that it's actually a really nice thing, and it helps out a lot. Let's see here. Question from Mark. Would you agree this is similar in C and C++ as directives, a pound include, pound define? I would not agree. Pound include is about, you know, taking contents of one file and putting it in another. Pound define is basically declaring a constant that is enforced by the preprocessor. So no, I don't see it that way. Yeah. So, Mark, is there a similarity that you saw that maybe I'm not seeing?
Just that it was compiler directives. It's something the compiler was using to do something, not necessarily what it was doing, but just the methodology.
Yes, thank you. In that respect, you are correct. There are certain, actually, does the your retention policy source, there's not really a way to say, oh, this is a compiler annotation. But yes, in terms of a hint to the compiler, or you know, a secret note sent to the compiler, yes, that's the same thing as the pound include and pound define, which are used by the C preprocessor. Yeah. I never made that connection before. I like that. Cool. Okay, so that was a tour of generics and a bonus tour of @override. Other questions that people have? You know, there was a goodly amount of discussion about the projects, getting started with the cones, getting started with the with project one, and I hope that everybody has at least got their code compiled, make sure their environment is all set up so that they can do the projects. Anybody still have questions about, you know, getting started and getting off the ground with the projects? A question from Max. Should we have set up a repo on the Linux servers? Do you mean, should you have a copy of your code on the school Linux machines? Aha. Yes, you should. And actually, let me show you how. It's not something that I did last week, and that's actually a very important thing for your assignments. Okay, well, so here we go. So I will SSH into the, SSH to the school Linux machines. So, but you know, we talked a lot about GitHub, and you know, we said, hey, GitHub's good for backups, and GitHub's good for sort of, you know, making sure that your code is in the cloud. So if, you know, you lose your laptop or whatever, you still got things. But there's another use case that I recommend using GitHub for, and that's moving files between machines consistently. So I know in my career, when I've used tools like SCP or got FTP back in the day, I am recording this, right? Yes, good. it was, you know, I'd always get it wrong. I'd forget a file, or I'd blow something away. Things were never in sync the right way. And one of the nice things about version control systems is that they are really good at keeping things in sync, and you've got a way to see the history and go back and forth and everything like that. So I encourage you to use GitHub as the way of moving your code from one machine to another, right? You develop it on your local laptop. You make sure everything is running. You get it to a good point. You commit that. You push it up to GitHub, and then you can pull it down into a local clone of your repository. So here I am logged into the CS department's Linux machine. Let's see here. Do I have a Git directory? I do. So I have a Git directory, and I don't already have one of these. No, I don't. Okay. This is where I like to keep my source code. And so what I'm going to do is I'm going to do a Git clone. Now, Git clone, what it does is it makes a local copy of the a remote repository. And so I get the, let's see here, I don't need this anymore. So I'm going to go to my Portland State Java Summer 2020. I am going to, I use the SSH clone method. You can also use HTTPS if you don't have your keys installed. And so I'm going to say git clone of that thing, that URL. Oh yeah, I don't have key tool running, which is fine. And now I've got a copy of my Portland State Summer 2020. I can go and look at the log just to make sure it's got everything I need. Yep, this is the thing I just did. And now I've got my, yeah, no git init. Actually, yeah, don't git init. You're not creating a new repository, you're just getting a clone of an existing one. Yep. So now I can, well, I can just go into like my phone bill. And let's see here. I think my Maven W is, yep, it is. And now I can do a Maven W clean and then verify. And now it's doing the Maven thing, right? It's downloading a whole bunch of stuff, and it's running my code here on the CS department's machines, right? And it's running all my unit tests, it's running my integration tests. It's basically doing the same thing I was on my local machine, but it's doing it on the CS machines. This is good. I think the CS machines still have Java 12 on them. That should be okay. If anybody runs into problems with like, oh, I was using Java 14 on my local machine, and that doesn't work on the Linux machines, please let me know. But I think everything is configured so that you're creating code that's compatible with Java 12. Where do I find the passphrase? The passphrase for what exactly, Max? Is it your Git account, or is it your SSH key? There was there's something that I went by. Let's see here. I mean, probably for the passphrase when I tried to clone for SSH key belief. Well, when you created your SSH key, you set a passphrase for your key store, and if you've forgotten that, you kind of have to start over again. So if it's for your SSH key, that what you need to do. Yeah. You know. So yeah, just pro tip: don't write your SSH passphrase on a post-it and put it on your laptop, right? Yeah, something I got to remember. Question from Andrew: we need Maven W clean verify on the CS machine just once per project, right? Well, once per every change. So yeah, I mean, if you if you haven't changed your code, yep, you'll need to run it once and it should be go, and then you'll be able to submit it. And we'll talk later about how to do that. But just like on your local machine, you make some changes, run, clean, and verify just to make sure everything still builds and all the tests still pass. Question from Tom: what should be the order of references if I get stuck on a part of project 1? Website, recorded lectures, EchoBook, Slack. Yeah, that's probably good. So if you're looking for concepts, yeah, start with lecture notes. They're PDFs, they're searchable. You can find stuff nicely there. Go back, and if it's something that you remember that I said in class, or you see something in a slide and you don't understand it, go and find the slide in the recorded lectures. The EchoBook is a reference, and it's not complete for the course. There's a lot of stuff in the course, like Maven and the REST API and stuff like that. It's not in the EchoBook, but it's really good. But the EchoBook is good for foundational language stuff. And Slack, it's not necessarily a last resort. I mean, if if it's taken you a half an hour to find and you still haven't found your question, maybe it's time to reach out. There's also Stack Overflow too. But yes, that's a fine order of things. So that's how you can get your source code. Actually, let me show you a couple more things. Let's see here. Where can the recorded lectures be found at? They are on the course website, which is, actually, I'll just show it to you here and I'll paste in the link. It's basically my homepage on the CS servers. And then Keith, you mentioned this last week, where will the recordings be? We'll always replace the current podcast links. They're right here under screencasts, right here. So here is where I post them. And they're long, they're all one big file. But yeah, it's all here on the homepage. So start with the homepage, bookmark it, tattoo it across your forehead, whatever you do. Okay. One more thing I wanted to show you with regards to getting code there. So like for week 2 screenshot, that screencast. Sorry, yeah, that is that's me talking. That's the lecture. So that's not this in-class thing, right? That's the lecture. The material hasn't changed in 2013. I'm investing in new things like Android. I'm not going to go redo telling you about Java I/O every year. So the new one will replace that. No, sorry. There's two things. There are screencasts associated with the slides, and then there's screencasts associated with the class time, which is this right here. Hope that makes sense. My wife's giving me a look like you're a crazy man. Oh, I'll be right back. Okay, and we're back. Sorry about that. Okay, so then, what I want to show you, are we going to submit the Project 0? Project 0 is not due, so no need to submit it. Do we need a higher Java version higher than 11 on the Linux server? Yes, you need to use Java 12. And just to be clear as a reminder, I think I showed this last time, you can use, so either you can modify your bash RC to define Java home to something like this. If you're like me and are an old school Unix person and are comfortable doing that. But the cat provides this really great tool called add package, which gives you this little curses interface to go down and do things like select the various packages to install, and this will take care of your how is it, your bash RC, is your CSH, I don't even remember, but anyway, if you're using this, that's a nice thing to do. Okay, one more thing. So let's see here. I want to show sort of the life cycle of making a change locally, making sure that it works, and then verifying it on the CS department machine. So I am going to, let's see here, phone call test. What's in phone call? Let's see if I can test something there. Let's see here. Get callee returns this method is not implemented yet. So, I already have that. Well, I'll just go ahead and implement something real quick here. So I will, I'm going to add a callee here. So let's just have one parameter here called the callee, and that's going to be a string. And we'll just have the callee be called callee. And oh yeah, it doesn't. I need to create a constructor. This will be a string callee, and we're not going to implement anything yet. And we call get callee. We want it to be equal to. It's not going to be like this anymore. It's going to be equal to callee. Oh, looks like do I want to change all that? Sure. There's only 3 of them. Okay, so I'll add that there. Great. And now when I run this, which you can do over here. I'm also going to use Control-Shift-10 a lot tonight. Control-Shift F10 tonight. It's rebuilding everything. Nope, it doesn't like something. Oh yeah, I also do it here. I'll go back and I will run it again. Yes, Andrew, thanks for that shout out for the fact that the Linux server is going to be down next Tuesday evening. So yeah, so your home directories won't be available. And so then, yeah, let's see, that's the day before the assignment's due. So, make sure that stuff either works before then or, plan on doing something else. Maybe Felicity's on during that time. I don't know. Go have some fun. Okay. So, yes, so that, so now the unit test is failing. Let me just navigate to it down here. Yep, it is failing because it expected the text callee, but instead is getting this method is not implemented yet. Okay, well, let's quickly go implement that. We want to say this is going to return this dot callee, and this doesn't exist yet. We're going to create it up here, and we're going to initialize it here in the this dot callee equals callee. And we're going to run our test again. Good deal, that passed. We're going to run all the tests just to make sure it didn't break anything else. All those tests passed, this is great. Now I'm going to commit that code to version control. Added the callee, callee parameter to the phone call class. And I'm going to push that up. I'm going to commit them here locally, and I'm going to push them up to GitHub. Going to do that. So that takes these changes, put in my local repository, pushes those changes up to GitHub. And now, over here on the PSU machine where I have my checkout, I can do a git pull. And what that does is it reaches out to GitHub to get any new changes that have come in. Sure enough, there are the changes that I just committed on my local machine. And now, now I'm going to run them again just to make sure everything works. So this is, this is a workflow that you go through when writing the test, and work as well when writing your projects, when working on the cones, all that kind of stuff. Where you make some changes on your local machine, you get them working, you push them up to GitHub, and then you can pull them down on the CS server and make sure that everything still works. And it does. Excellent. So, and I recommend that you use GitHub for this. I mean, sure, you can copy them over, in other ways, but this is just super easy, and it teaches you how to use GitHub. Okay. Any other questions before we dive into some other stuff? Oh, let's see here. Question from Chad. You just ran Maven verify again. Yeah, I did. How did version control work before Git? Oh, that is an interesting question. The concepts, the concepts have really been around for 30 years now. The whole idea is that you've got multiple people that want to collaborate on the same code base. And you've got some problems when multiple people do that. You have people that make changes that are that can be independent of each other, and then changes that can be dependent on each other. And when two people change the same code, how do you sort of weave things back together again in a way that makes sense? And this is sort of the problem that version control systems were meant to solve. Over the years, there have been a number of generations of version control tools. Some of them were just kind of glorified backup systems, which is very, very helpful. And some of them, would tell you when there was a code conflict, but it made it kind of hard to visualize, and how do you resolve it? And I guess another use case that that has evolved over the years is the whole concept of branching, meaning that you have, some people are working on a code line up here and making changes, but then maybe you want to go off and do something different, maybe something that's pretty impactful, allow people to work in parallel. And then at some point, you want to take your changes, merge them back up to the place where everybody else is running. It's kind of beyond the scope of this class, and I don't really want to take the time to go into it. But certainly, take a little bit of time and read up on GitHub read on Git. To understand all about branching and merging and tagging. These are important tools for software engineers. Glad you found it interesting. Okay. Sweet. Okay, I'll take another sip of water and then get started on other stuff. Okay. Oh wait, how do we get blah, blah, blah to build a project? Sorry, how do we get Maven Clean Verify to build a project without building the student project? Mine fails because I haven't implemented the student appropriately and skips the phone bill project. Go into, if you just CD into the phone bill project and just build it there, you won't build the student project. You're probably building things at the top level. CD into the phone bill project, you should be okay. What we should really do is get your student project to work. But yeah, that's kind of everything. Okay. Oh, neat. Cool. Sounds like a slide deck about Git from the full stack teacher. Thanks, Tom. Okay. Now, last time we wrote, we began the Project Zero, the student project. And over the, and we wrote a bunch of tests for it. And actually, let me find student tests. I guess I don't have it up. I will go find it. Student test. There we go. I will move something to the right. Sorry, my daughter has me a question. So she's like, Dad's teaching his course. Maybe he'll let me have ice cream for dinner. No. So then we have student tests. Let's see here. So move right. We have this side by side. So a student takes a bunch of classes, has a GPA, all that good stuff. And over the weekend, I implemented some more functionality to do all of the formatting of the classes in the toString. So we've got that much. And so what I want to do now is I want to implement the rest of the functionality of the student toString to eventually realize this. Let's see here. I'm going to close the chat window. So if I don't respond to your chat, then just unmute and speak up. But I'm going to, where is that? There was like the ultimate test case. Oh, right here. Yep. So it's, I expect that the toString for that Dave object prints out this whole big thing, taking 3 classes, and he says this class is too much work. So if we look at where we are right now, we run this, and it's got to build everything. It fails right now, and if we go and look at the difference, we'll see that it gets the first part of the toString right. It has the Dave has GPA of 3.4, but it doesn't have this second part, which is he says this class is too much work. So let's go about implementing that. So let's see here. Now there's a couple of things. I'm going to actually just revert that so it's still ignored. No, need to import it again because it unimported it. Okay, so we need to implement a couple of things. First of all, that all students say this class is too much work, but let's focus next on the gender pronoun. And there are three gender pronouns. There's he, she, and they. And so let's have the first test, which is, oops, public void female student has she pronoun. So we'll create a female student and remind me what this is. The name is her, and we'll just have no classes, doesn't really matter. New array list, GPA of 3.78, and oops, it's like that got all messed up. And now the gender will be female. And well, let's see here. We could say assert that female dot toString contains string she says. Okay, let's run that. Okay, not surprisingly, it fails because it doesn't contain that string. Okay, so now let's go. What's all this stuff over here? Stuff I don't need. Now let's go to the student class, which we brought up over there. And here now in toString, this is the stuff that I implemented over the weekend. Well, let's see here. Well, in the spirit of Uncle Bob, let's just do the thing that works, and then just have it say she says. Okay, and run it again. Nothing wrong with that. It's the simplest thing that could possibly work, and it did. So let's leave it at that. But now let's have a little bit more of an interesting test case. Let's see here, duplicate. And then let's see here, other student has they pronoun. And then this is a gender of other. And they say, I should say they say, yep. They say. Now, obviously, when this runs, this ought to fail. It does, because we are expecting they say, and it says she says, because that's the way it's there right now. So here's what I'm going to do. I'm going to refactor this into a method. I'm going to refactor this extract method. And then it's going to be get pronoun. Pronoun says. Okay, yeah. Try that. And now I want to put the conditional logic here based on the gender. Okay, so let's see here. How should I best represent gender? Right now it comes in as a string. That's okay for now. I'm thinking in the back of my head, the thing about gender is that it has one of three values, and so a string can have any value. So I'm gonna have to reconcile that at some point. But in the meantime, let's just do this. And that's the nice thing about code. It's easy to change, and you can always change it later. So what was I complaining about? Oh, it's never accessed. Well, that's fine. Now down here, I say, oh, you know what? I'm just going to use a switch statement. So switch on this dot gender. Some people don't like switch statements. They have their uses every once in a while. Case male. No, sorry, female is she says. And then case other is return they say. Let's give that a try, see how it works. Oops, I don't have a I know it won't work because it's telling me it won't compile. So because I need a default. And here I'm going to say throw new illegal state exception, unsupported gender, and then gender. It didn't compile because one of the things that the Java language requires is that well, all code is reachable, and that and that all methods that have all non-void methods have a code path through which a value will be returned, or an exception will be thrown. So here, because there wasn't a default, if the gender wasn't female, wasn't other, it wouldn't know what to return. So instead, what you have to do is throw an exception. It's like, wait a second, you're never supposed to get here. And so you throw an exception, and the compiler then is smart enough to know that all code passed through the method will eventually return either a value or will throw an exception. So the method will exit. Let's try running this again. Okay, that passes. Let's try running everything again. Oh, all sorts of things blow up. Oh, guess what? Oh, yeah, right. I had all of these student tests that now that call to string, and I had used this like doesn't matter. But now I guess it does matter. Okay. Okay. So what I'm going to do then is I'm just going to replace that with other, I guess. That ought to work. So let's see if I get them all here. Oh, this was a capitalized, doesn't matter. So I'm just going to do, oh, what is it? Edit, replace. I know the, I knew, sorry, I can't find it here in the menu. I know the keyboard shortcut, it's Control-Shift-R for replacing, oh, sorry, wait, that's replacing path.
Professor, what if you made the default in the switch statement, they say?
Well, actually, it's not correct though, right? I mean, it would make all the tests pass. Yeah, maybe I should do that. Because, according to the assignment, let me get the assignment up. And maybe I'm sort of skipping ahead of myself. Yeah, I mean, you're asking a good question. The gender is male, female, or other, case insensitive. What's the behavior when you have a choice other than that? Seems like it should throw an exception because it doesn't know. It's not a legal value. And yet, I've got it all over the place. So, but I don't have a test for that. So yeah, I think so. You're right. The right thing to, I'm going to comment this. Nah, I should delete it. I guess, in the spirit of let's make the code pass as it is, and then introduce a test for for any new functionality. I could just do that. That's a good idea. So let me see how that runs. That's probably okay. Yep, you are correct. Okay, so I'm going to commit this. Yeah, okay. Let's see here. Implemented female and other gender pronouns. Oh, wait, push that up. Okay. And I guess we'll do male next. Male student has he pronoun. Him, male, and then he says, yep, and here again. Okay, so now I just need to add one more here. This will be male, he says, run it again. Okay, so that passes. Is someone asking a question? Oh, gee whiz, I'm sorry. There are probably some chats going by. Make the default to they. Yep. And so, yeah, Lawrence suggested an enum, and that's where I'm thinking too. So let's figure out to do let's figure out how to do that. But yeah, and then Luke asked a good question. Why didn't you have to explicitly call out the exception in the method signature? Very good question, right? Like when we throw IO exceptions, stuff like that, we need to declare it. There are two kinds of exceptions in the Java programming languages: checked and unchecked. Checked exceptions are required to be declared in the signature, and unchecked are not. And think about it. There are exceptions like null pointer exception, array index out of bounds exception. You don't have to declare those every time you reference an object or reference an index into an array. Those are unchecked exceptions. And things like legal state exception are unchecked exceptions. And all of those unchecked exceptions are subclasses descend from Java Lang runtime exception. There's in one of the lectures I cover all of that, but that's why. So you'll see things like IO exception, which is checked, and so whenever you call something that reads a file or whatever, you have to say, oh yeah, right, this might throw an IO exception, and you have to explicitly catch that, as opposed to a runtime exception is something that you're really not expected to catch. And is often easy to check for. So things like, here again, null pointer exception. If you're worried about something that's potentially null, check to see if it's null first, and then handle that appropriately. Okay. Let me quick submit this. I should have done that before. No pronoun. Okay, I'm just going to commit that. Oops. Okay, so we've got this. Gotta keep the chat down there so I can see it. That's as small as I can make it. Okay. So now there are only three. The program only accepts 3 valid values of gender, and I want to model that. I think that'll make the program a little stronger, a little bit more resilient, because really we shouldn't just accept unknown or potentially invalid data. So now I want to test. I want to test it. So let's see here. Student with student with unsupported. We'll say unsupported gender throws. Oh, how about we have it throw an unsupported gender exception? Yeah. So here, supported. In here, this is something that's unknown, so we'll just call it unsupported. And actually, just creating this. Oops. Sorry, I should make it a little bit more clear by renaming these. So this is other, and this is male. And here we don't even need the variable because we expect the constructor will throw an unsupported gender exception. So in JUnit, when you have a test that you expect to throw an exception, what you can do is you can add it to the expected value of the test. And so then this is going to be something called an unsupported gender exception, and you use the class reference there. And so then here we're going to create the class. We're going to create it in the main, in the student main. We'll just put it in that same package. Poof, we've got it right here. And it extends throwable. We want it to be a runtime exception. Yeah. Okay. And so now it's saying it doesn't need to be public, and that's fine. We get package private. So now if we go back here, what does it complain about? Annotations are not allowed here. Oh, I put a semicolon there. That's why. That ain't right. There we go. Now it's happier. Okay. So now, oftentimes, not oftentimes, there are situations where it's perfectly fine for a code under test to throw an exception, right? You give it bad data, it throws an exception. This is what you want to do. You want to have a test to verify that it has the correct behavior. In this case, the correct behavior is that it throws an exception. And so then, the way you capture this in a test is by saying, hey, I expect that an unsupported gender exception will be thrown by this code. Now, of course, we run it. It should not be thrown yet. We don't even have one of these. Great. Okay. So here's what I want to do. I want to implement gender as an enum. Now, I don't know if you've studied enums in C, enums in Java are very similar. The whole idea is that you've got a type that only has a couple of instances. So for instance, colors, red, white, and blue, and orange, and yellow, and green, right? There's only a handful of these things. You don't just have an arbitrary color. There are predefined ones. And here, there's only a handful of genders that are supported. So instead of gender being a string, I want it to be represented as a gender enum. It looks like I had one in a different package. I want to, oops, interesting. Can I get, no, stop it, you. I don't want to use that. I want to do something else. It will not let me just create it. Fine, be that way. Inside the student class, I then want to declare an enum called gender. And now, is it happy with it? It is. Okay. And I'm going to put a, gender value of. No, I don't think I want that exactly. I want to say, yeah, I can't override that, or can I? No, get gender for string, and then the gender parameter. So it'll create a method here on the enum. I'll call this gender string. And now here I'm going to have another switch statement. Am I? Yeah, why not? Okay, so I'll have another switch statement, and I'll switch on the gender string. Actually, well, okay, and I'll implement that later. And I will say the following. I will say when we have female. I'm actually going to take that. Yeah, I'll go back and change that later. I'm going to return gender dot female, and this creates a enumeration constant. Oh wait, that's not what I wanted. No. I wanted to create enum constant female. There we go. Cool. I want that. When it's case male, I want return gender dot male and create an enum constant for that. When the case is other, I want to return gender dot other enum constant there. Right, so the whole idea is that there are only three values of this enum, and these are all objects, but it's like three magical instances of gender. And now, when I, now I want to say default. There we go. Now I'm going to throw the new unsupported gender exception. And I want to, let's put in the gender here, the gender string right there. And I'll add that to the constructor like that. Yes, 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 oops. And I don't need that there. Oh, someone else just showed up. Okay, so now when I run this, I should have, oops, I didn't, oh, haha, this dot gender. Okay, well, it'll make me fix it anyway. So this dot gender is now, it's not a string anymore. It's one of these genders. So now I just need to call it, now I need to change it to be, can I just say female? I can, great. Now I want to reference the constants. And now I want to say, oops, case other. And I want to say this. Now, if someone complains because they don't have a default, this should not, this should be dead code. And then throw, so this is, I'm going to say a legal state exception. And it's like, how did I get here? I'm trying to think, is there a better way? Oh, there is a better way to do this. Actually, but I'm gonna try to run it first. I have a refactoring that I think will make this code a little nicer. So many windows. So student test. So now I'm going to do this instead. Does the switch statement need breaks? No, it does not, because I'm returning. Yes. Yep. Makes sense. Okay, great. That works now. Okay. Now, I do need to go back and fix a whole bunch of tests. So let me do that real quick. Right, because there a whole bunch of other stuff could blow up, because now we're checking the validity of the, of that unsupported gender exception. Oh, this is interesting. Unsupported gender exception doesn't really print anything. I'm going to go and fix it. So if you look at, there's an inherited constructor that takes a message. So I'm just going to send in the gender string there. And so now when I run these tests again, I'm going to get a little nicer error message. It tells me, okay, yeah, this is the supported gender, doesn't matter. So that's nicer. That helps you out. So now I'm going to go, I'm going to do, let's see here, replace. No, replace, there you go. I'm going to say doesn't matter with just other, and I do not want to match case. I do not want to preserve case. Let's just see what happens when I replace all. Looks pretty good. Let's try running them again. Yay, okay, everything's passing. I'm going to check in my code. I'm going to try a refactoring, and I may or may not take it. So I'm going to say added support for checking the, for unsupport, as support, no. Ensure that the gender is supported. Commit. So, I don't like this switch statement. As a matter of fact, there are some people that just think switch statements are awful. It means their code's not object-oriented enough, blah, blah, blah. In this case, I think they're right. Anytime like I've got something like this, it's like, oh, I had to write some dead code in order to get to compile. That's lame. That doesn't seem right. So here's what I'm going to do. I'm going to put the determination for what the gender pronoun says, what the pronoun says on the gender itself. Why not? So I'm going to do the following. So instead of the switch statement here, I'm going to say return this dot gender dot get pronoun says. I'm going to create that method on the gender enum like that. Oops, I didn't spell pronoun correctly. And then I'm going to say this dot pronoun says. I'm gonna pronoun says. Gonna rename that. Let's see here. See here, Alexander, when I create the exception class in my student.java file, Oh, sorry, my student doesn't recognize it, can't import it or something. Make sure it's in the right directory. IntelliJ might have put it off in the IT directory. It does that because it doesn't recognize as a test directory. So make sure that the .java file got put off in the main, the source main Java, not the source IT Java. That's happened to me a whole bunch of times. That's why I need to do it. Yeah, I know, right? Live and learn. Okay, so now I'm going to add to my enum. See, enums are just classes, and so you can do things like add methods and fields to them. I'm going to add a nice. I'm going to add a field to it. I'm going to add a constructor to it, and it says yes, please. Oh no, wait, default value. Fine, whatever. Yep. And now I'm going to put in things like up here, she says, he says, they say. And so now oh wait, that thing, yeah. And so now I don't basically this method can go away. So I'm going to refactor this. I'm going to inline it, meaning get rid of this method and just replace it with the code that's inside that method. So I'm going to say refactor, I'm going to say inline. And yes, inline all the one occurrence of it. Poof. Now it's doing that. So what I've done is instead of having to have that like awkward and that awkward switch statement, now I've moved all that functionality into the enum. So now the enum knows what it says. In this case, I think it's okay. You don't want to do that. I mean, I don't know if it's something you always go to, but I think it's okay to do that here. This gender is only used inside this class. This is kind of first class functionality. I think this will be okay. And I think I made the code. At least I made the two-string code a little more simple. I think this will work okay. Just let me run all these tests and see if it still works. So I got to do a little bit of refactoring on this code. And this is the thing that you'll find. I mean, when you begin writing your code, there's not a lot of opportunities to refactor, but as things get more complex, as things get more featureful, there's more opportunities to refactor. Nice. I did that. Okay. I'll quick commit that. Let's see here. Refactored the code that determines the gender pronoun to be closer to the gender enum. Okay. So I want to write a couple more tests, and then it'll be time for a break because I've been talking for a long time. Okay, so let's go back to I can't find it here. Let's go back to to this one and see how close we're getting to having everything complete. I wrote this test to sort of say, hey, what is like the ultimate goal of the student class? What's the thing that's got to work? It's still failing, but we've gotten a lot closer. Great. He says this class is too much work. Well, then we're almost there. I want to have, let's see here. I want to have test public void all students. Yeah, say this class is too much work. So let's see here. Let's create my Dave student equals create Dave student. And I'll assert that Dave.says equal to this class is too much work. Failed. Yep, Peppa was hello. And I think that's because I commented something out. Yep. Commented this thing, so I will uncomment that, and I will return this class is too much work. And I'll run it again. Cool. I'll go back to my right. I'll go back to this one. Now I think this one is almost ready to pass. As long as I say the following, and then I append this dot says, and then I'll append a period. I think that's what I need to do. Oops, what doesn't it like? Probably something subtle. Oh yeah, I forgot the double quotes. Oh, I need a space and stuff. Once more with feeling, yes. Yay, all set. Okay, so I've gotten all my, actually, okay, so let's see here. Let me check it in. And I will say added the functionality for all students saying this class is too much work. Commit that and push it up. So I've been doing test-driven development, and at some point, you got to ask yourself, am I done? Now, I know when I'm done, when I've refactored all the code that I've written so far to a point where I'm happy with it, and I can't think of any more tests to write. So for the student class, for this, fundamental functionality for the toString method, are there any other tests that we can write? Anybody have any ideas? Feel free to raise your hand or put something in chat, or everybody asleep, probably. Empty name. Oh, there you go. Good. Yeah, some edge cases. Okay, so then what should happen? And a student, well, or just student with an empty, oh, sorry. Empty name, throw an error, okay. Throws illegal argument exception. Okay, so, okay, oh, no GPA. But what do you mean by no GPA exactly? Because it's a required, so, well, anyway, we'll get to that next. I like that. So new student with empty string for a name, and then takes 0 classes, and then has a GPA of 3.45, and then has a gender of other. So we expect this thing should throw an illegal argument exception, we said. Okay. Oh, Asher again asked about the what's going on in the line 131 with the expected. I covered this before, but I said it really quickly, so I'll reiterate. Sometimes you expect that a test is supposed to throw an exception, and what we're testing here is like, hey, let's send some invalid data to the constructor, and what should happen is it should throw an exception. So the way that you validate that the exception was thrown is that you say, yeah, this test expects to throw an unsupported exception, and if it doesn't throw this exception, the test should fail, which is what we'll see right now with this empty name. So when I run this one here, it fails, and it says, oh, I expected there to be an illegal argument exception, but one wasn't thrown. So now we should do that. Let's see here. So if, well, name equals empty string, throw new illegal argument exception, name cannot be empty. Okay, now we'll try it. We'll run that test again. And it passed because this time, yes, an illegal argument exception was thrown. This is what was expected, and the test passes. So Cyrus says, oh, yeah, we should test no GPA. How do I write that test for no GPA? Oops.
I was just thinking, don't pass it to the constructor.
Okay. That code won't compile, right?
Well, couldn't you say just like before that you're expecting an exception?
Well, but it doesn't even get that far because the code won't run, right? So if I don't have, oops, array list, and if I just leave it out, if I just have then a gender, it doesn't compile. I can't even do that in the first place. Now, you might be thinking ahead to the command line, and we're going to get there after break. But I don't know how to write a test for that because the compiler does the testing for me, right? It won't let me.
I guess you could just do if it's above 4.0 or.
Oh, okay. Yeah, I like that.
Something like that.
Yeah. So let's see here. GPA higher, greater than 4.0 throws legal argument exception. We could create a new one. Create a new exception type, but let's not. And here, okay, so we'll have this is the GPA, so 4.5. Okay, so that looks like it's going to compile. We'll run it and it'll fail. Good. Yeah, good question of using null. Actually, can we have? Oh wait, sorry, I didn't do that right. I need to have an expected legal argument exception. Is what I think I had. I'm gonna close the participants again. Yep. Okay, now it should fail. Oops. What does it do? So good questions about, hey, can I use null? Is there a none type? Not like there is in Python. Yeah, Java, especially with Java primitives, you can't do that. Here again, it failed. Can I put null there? I don't know if that's going to work. Nope, it won't, because null is supposed to be sorry, I can't see here because of this. Yeah, you can't cast a null to a double. You might be able to do this. I don't know. Yeah, but it's like, that's weird. You're going to get a null pointer exception if this runs. That's what I bet happens. Yep, you get a null pointer exception. So that's not really what we want either. So I suppose you could, no, actually, well, you have to change some things. So no, I think what we want is something that's, that's its big. So let's see here. Let's run that again. Nice. Okay. Let's see here. If GPA is greater than 4.0, throw new legal argument exception. GPA is 2. GPA cannot be greater than 4.0. So you can imagine a lot more of the, a lot more of these boundary cases to implement. And we could take some more time and do all of that, but it's getting time for a break. But I want to leave you with this. The way that in test-driven development, the way that you know that you're done is that there aren't any more test cases that you can think of. And because you only wrote code that had tests, you know that your code is done too. Right? There's no other code that you need to add. You can go through and refactor things, but refactoring shouldn't add new functionality. You have unit tests to make sure that it doesn't actually, that it doesn't break existing things. And this is good, and this is okay. This actually gives me confidence. It's like, yeah, I think I've done everything I can. Then, maybe, hey, I wake up in the middle of the night and realize, oh, I didn't test something. Great, I added, I didn't implement something. I had a test for it. See, the test fails because it isn't implemented yet. I implement it. It's passing. I rerun all my tests to make sure that everything, nothing's broken, and poof, I can go back to sleep knowing that my code is solid. And really, that's what we're trying to do here. We're trying to write code that we understand, code that is validated automatically and quickly by a suite of tests, and that gives us confidence that it's good code. Okay, I'm going to check this in. Let's take an 11-minute break. Let's reconvene at 10 minutes now. Let's come back at 7 o'clock, and we'll talk about integration tests next. I'm going to pause the recording.
Sorry, I interrupted your break.
That's all right. No, I put my headphones back on. It's all fair game. Sorry, and I will follow.
I'll re-ask the question.
Yes,
for
please.
The recording.
Yes.
So the question is, I'm just not a question really. I'm just very confused about what role Maven should play during development. Do we need to build all the time with it, or what's going on with it?
That's a good question, because you're right. I mean, look what I'm doing now, right? I'm writing tests, I'm getting code to work and everything. I'm just like committing off to GitHub. I think it's a good idea to run things periodically. Hey, I've been coding for, I don't know, half an hour, whatever it is. I want to make sure everything still works from Maven. Because ultimately, that's what I'm going to use to build your code with. So yeah, you need to make sure that it works. But no, you don't need to do it like on every TDD cycle, not every red-green refactor cycle. So I guess definitely make sure that it still works before you submit, right? That would probably be like the last time. But before that, I don't have like a good rule of thumb.
Okay, so but like maybe once a check-in or something.
Yeah.
Okay.
Yeah, and sort of like, it was like, has it been too long? Does everything still work? And luckily, these projects, well, project one, the command line arguments, they build pretty fast. When we get to the web project, and certainly when we get to Android, there's a little bit of there's more stuff that needs to be done, so you probably don't want to be going back to the command line all the time. But yeah.
Thank you.
No problem. Actually, yeah, and someone asked for the Slack channel again. I will post the. Let's see here. Get an invite link. 7 days. Invite link. Copy. Okay, and there's someone in the waiting room. Nice, okay, let's get started again. Okay. So there was so Mark had a question right before the end of or before break, and I wanted to be sure to address that. That was a really good one. He's like, okay, I'm doing this TDD. Once we're done writing our code, is there a way to remove the testing stuff to reduce bloat in the shippable code? I'm going to answer that question another way, which is like, you shouldn't be shipping your tests. There's no reason to ship tests. You don't want to delete them. Right, you want to keep them around. So as you make more changes to your code, you have this whole suite of validation that you can run. But no, you don't ship your code. And this is why Maven puts the test code in a different place from the source code. Maybe I'll just show you in IntelliJ instead. So if we look at our project in IntelliJ, here we are in our phone bill, and there are in the source directory, there are 3 different kinds of source. There's the main source, and the main contains code like okay, I'm doing phone bill here, that's fine, right? Phone bill, phone call, project one, this is like all the application code, right, is all here in main. And there's test code, which has your unit tests, the phone call test, and then what's the project one test? Oh, this is all about the README. Yeah, we'll get back to that later. And actually, and so then when Maven builds your code, though, so I'll go into the phone build directory because that'll be most let's see here. I guess I just built this recently. That'll be most familiar to you. If you look in the target directory, so Maven puts all the compiled, all the built artifacts, all the class files, all the jar files, and everything like that, any documentation that's generated into a directory called target. And it puts it all in one directory so that when you go and clean, you just need to blow away one target. Oh, sorry, one directory, the target. That makes it nice and easy. So here's all sorts of stuff like, yeah, generated source code and your classes, your classes and your test classes and stuff. And it also creates jar files. Now, jar files are Java archives. They are a bunch of class files and resource files or anything that you need to run an application or to be a library. They're all in one file. It's easily distributable, and we saw that when you run, you can use the Java-star option to run your main program like this, right? So 1, 2, 3, and we'll be talking about the main program again very shortly. So that's all here in the jar file. If you look at the contents of that jar file, you will see that it contains a bunch of class files, some other stuff like that. But what it doesn't contain is any test code, because you don't want to ship your test code. You don't want, right? Because you're right, it is bloat, it's extra. It's not something the user is going to run. This is something that you, the developer, runs to validate that your code is correct. So you don't delete the source code, but you don't ship it. You don't ship the compiled class files either. Mark, did that answer your question? Hope so. Ronnie also had a question. Can I use the IntelliJ Maven plugin to run Maven lifecycle instead of running on the command line? Yes, I believe so. Honestly, it doesn't really buy you that much because, as we were just talking about, you're not going to run Maven that often. And when I run Maven, I'm going to run it from the command line. So actually try it out, but then also double check to make sure that it still works from the command line. I don't know if it'll use the Maven wrapper or not. So yeah, I don't use it from IntelliJ. I know you can. It's over here on the side. And so that's kind of neat. I don't know. Let's give it a try. What's complaining about student dependencies? I don't know who doesn't like. Huh. Interesting. Okay, well, I was complaining about something. But yeah, so let's see here. So actually students. Yeah, so if I run verify. Oh, look, it's doing stuff. Yeah, it blew up for something. Okay, it's not happy here. Huh. So, okay, so it doesn't like it where it's fine on the command line. So I don't know why. What version of Maven is it using? Can't tell. It might be an older version of Maven. Oh, yeah, here it is. Yeah. So it's using Maven 3.3.9. So maybe there's some way to update IntelliJ. I don't know. The advantage of the Maven wrapper is that you don't need to worry about all this environmental configuration, right? I've made it so that you just use the Maven wrapper. It downloads the right version of Maven. It runs the right version of Maven. And so, yep, you got to figure out how to get your command line working. But that's a good thing to know how to do. If I'm going to test on Linux server, do I have to upgrade from Java 11 to Java 14? Java 11 should be sufficient. Java 12 is definitely sufficient. What we use on the PSU Linux machines is Java 12, unless somehow it doesn't work, but so far so good. Nice. Oops. Okay. So yeah, those are some good questions. Thanks for asking them, everybody. Let me get back to here. Okay. So in the beginning of class, we wrote a bunch of unit tests for our student class, and as far as we can tell, the logic of the student class is all set. The toString method does exactly what we would expect from the assignment. It prints out all that information that's passed in the constructor. But the project isn't done yet, right? The project is the student class, but also the student has a main method. And the main method takes in the command line arguments, and it parses them, creates a student, and then prints out the toString. Now, the main method does, the main method is a little different from the rest of the code. The main method is the user interface, if you will. It's not a graphical user interface, but it's the user interface for the user. And it takes the input from the user and it provides output back to the user. And it does this in a couple of ways, right? It reads the stuff from the command line. It reads the command line arguments, and then it prints out the toString of the student that was created, if the student was created successfully. If the student isn't created successfully, it should print out an error message, and it should also call system.exit of 1 or with a non-zero. Now, we can write that code, but we want to test that code because we're doing everything test-driven development. Now, if I have a unit test that calls some code that invokes system.exit, that's going to exit the unit test VM, and we don't want to do that, right? If we try to do that, you'll get a complaint from the JUnit engine saying it's like, listen, the VM exited unexpectedly. I don't know if all the tests ran. Something's wrong here. Don't do that. But we still want to have automated tests for our main method. So we talked about unit tests, which are all about validating the logic of a unit of code, like a class or a method. There's another kind of automated tests called integration tests that are meant to test how multiple things are integrated together. Now, oftentimes we think of integration tests as testing sort of big things like, a web client interacting with a web server, or, a program interacting with a database, things that require setup and that they're usually much slower because they're doing a lot more. They're not just executing a little bit of code, they're going over a network connection or reading lots of stuff from a file. But for project 1, we're going to use integration tests to be able to exercise our main method. And so this way we can write our main method using test-driven development, which is actually pretty powerful and kind of nice. So let's see. I'm going to leave the chat up. So we have, and actually, sorry, let's look at where that code lives. So I was just talking about, I'm going to look in students at a phone bill. I was just talking about these directories that are under source. We have the main for our main application logic, and so this is where student lives. We have our test, which is for our unit tests, right? And so here's student test. There's also this IT, and IT stands for integration tests. And in here, all in the same package, notice they're all in the same package, but they're in different directory hierarchies. We have something called student.it. So let's open up that student.it. Now this is an integration test. And so this tests the main method by actually using some little magical framework that I wrote. Because I want to be able to validate things like, hey, listen, when I invoke my main method with no arguments, the system.exit of 1, exit 1, is called. And so what I did is I wrote this invoke main method and this main method result class to provide a testing framework for main methods. It has some magic. You can go look at the source code to see what the magic's like. But it has some magic for doing things like catching the value that is sent to system.exit and capturing it so that you can then later interrogate it as part of an assertion statement. It also captures the text that's written to standard output and standard error so that you can validate that also. People are slacking, and I'm not going to pay attention to it right now. So if you want to get my attention, please use the chat in the meeting. So let's take a look at these tests. So invoking main with no arguments has exit code of 1. So the first thing I do is I call this invoke main. I give it student.class. It says, hey, I'm going to invoke the main method of student.class. And it's going to go off and do that. And it's going to encapsulate the result of invoking main into this main method result object. And I'm going to say, okay, result.get exit code. Result has some other stuff. It has some other stuff too. You can get the text that was written to standard error and standard out, and you can get its exit code. So here we're going to assert that system.exit was called with 1. And sure enough, if you go over here and look at the main method is pretty simple right now. It prints missing command line arguments to standard error and calls system.exit of 1. So here in the invoking main with no arguments has exit code of 1, we validate that. And now in here, in the second test method, integration test method, invoking main with no arguments prints missing arguments to standard error. So sure enough, you do that same invoke main with no arguments. Oh, and by the way, you can have optional arguments to that method, and we'll see examples of that shortly. We'll make sure that the text that was written to standard error contains missing command line arguments. So we're going to start with a main method. So the out-of-the-box main method does that. And so when we run these integration tests, what these do is they end up calling the main method and then capturing what the main method does, how it interacts with standard error and standard output, and what it sends to system.exit. And sure enough, both those pass. Okay. We'll see some examples of this shortly. So, okay, let's go back and look at what the command line does. The command line first takes the name, then the gender, then the GPA, and then the classes. And then the remaining arguments are the classes. So let's see here. What is the first test case that we want to write? Fewer than 4 args, Chad says. Great. Okay. Let's see here. Yeah, that's a good one. Just one argument for the name? Okay, well, but what happens if you just have one argument? So let's see here. Let's do that. Public void, only one argument prints. What was the second argument? You just have Dave, you need male, so be missing gender. Missing gender to standard error. Okay, so we're going to say invoke main. It's going to be the student.class with the argument just the name. And we're going to put that into a variable. We're going to call it result. And what we want to say? We want to say that result.get text written to standard error contains string missing gender. And let's also, while we're here, assert that result.get error code, exit code equal to 1. Let's run this. Okay. Expected a string containing missing gender, but instead missing command line arguments. That's right, because right now we're not doing much. Okay. So let's see here. How can we get this to pass? Well, let's see here. If args.length equals 0, then else. Else. Yeah, so else. Yeah, why not? And we'll say missing gender. I do see that question being asked, but let's run it again. Luke asks, invoke main, is that a method you wrote, or does it come with Gina? It's something that I wrote. Yep. If the user tries to run with only the argument male, they might find the error confusing. That's correct. What would be a better error? And this is one of the interesting things about command line parsing, right? How do you know that what the command line arguments are supposed to be? You should probably like print some help or something like that. And we could implement that. Let's see here. Listing out requirement arguments, maybe. Exactly. Right. So in addition to saying missing gender, you should probably also print out some help information. Yeah, usage. Yeah, exactly. And as a matter of fact, well, of course, you all knew to do that because it was part of your first assignment. So you've probably all been doing it. But I'm not doing the assignment, I'm doing the student. So, you know, no one's grading my stuff. So, but that's right. The right thing to do is to have some usage information. Okay, great. I got that working. Let's make sure that everything else still works. It ought to. I think I was pretty careful with how yep, okay. Good deal. Okay, well, let's keep going. So let's see here. What's the next thing? We should probably, let's see here, name, gender, GPA. Okay, let's see here. Let's have something very similar for no GPA. Oops, let's figure out how to make this stuff smaller. let's see here. Only 2 arguments. 2 arguments. Prints missing GPA. GPA. So now we want name, and then we want gender, other, and then this will be missing GPA. We run this. It fails because it was saying missing gender because I just had an else here. So let's quick go fix that. So let's see here. This is, oops, what the heck did I just do? Else if args.length equals 1, say missing gender. Otherwise, we want to say else if, well, we can just say else. Yeah, let's just say else system.error.println missing GPA. Nice. What happens with 3 arguments? Three arguments is valid, right? So that creates a valid student. So okay. So let's see here. Student can take 0 classes. So let's see here. We want to invoke main. We want student.main. We want it with name, valid gender, and a GPA, 3.45. In here, oops, and this is valid, right? So this should be accepted. So we should assert that result.getExitCode is equal to 0, that it's happy. And we should also, let's say it's a valid student, so we should write out some information to standard output, right? So assert that result.getStandardOut contains string, let's see here, name has a, I'm going to put this in a variable so we can see it more easily. Contains string description. Name, that's terrible. We should call it name. We should call it Sumit. Sumit has a GPA of 3.45 and is taking 0 classes They say, I'm going to split that over 2 lines so it's easier to read. Plus, they say this class is too much work. I think that's right. Okay, let's run that, see where we're at. Expected 0, but was 1. Yep, we expected an exit code of 0, but instead we had one of 1 because we always return 1. Well, so let's fix this. Let's see here. We're going to use system.exit in all of those. Here we're going to have a system.exit of 1. Oops, what didn't it like? It says it's still, oh yeah, right, yeah. Else if args.length equals 2. I missed an opportunity to show you something. Okay, I have a failing test, and I don't understand why the test is failing. So I'm going to debug the test. Now, I think most of you have used a debugger of some sort. I think you use GDB or something from in your classes. IntelliJ has a very nice debugger all integrated in. So the way, hopefully you're familiar enough with sort of debuggers, the whole idea is that you've got your source code and you set what are called breakpoints in your source code saying, hey, listen, run the program in a special mode such that when the line that where the breakpoint is defined is executed, stop the program there, and then I'm going to use tools to to inspect my program to see what's going on. So I'm going to set a breakpoint here at the beginning of my method, my main method, and I'm going to run my integration test under the debugger. So now it reruns the test. And it's invoked my main method. So it's invoked this code over here. It's invoked my main method. And now it's telling me some stuff about my main method. So this is cool. I'm stopped right here on this line 121. It's telling me that the value of this args array has sumit, other, and 3.45. And now I'm going to use the debugging tools down here to walk through my code. I'm going to use step over because I'm just going to go line by line. I don't want to go into function calls. So I'm going to see, where's my code go? Okay, if args.length is 0, nope, it's not. If it's 1, nope, it's not. Otherwise, print missing GPA system.exit1. Well, there's my problem right there. It's not missing a GPA, but I have a logic error in my program because I said else when that's really, when I have 3 arguments, that isn't the right case. So I'm going to, I guess let's continue, resume program execution, which means keep running. And then if we go back to the console, we'll see that the assertion error failed. So now I need to fix that by saying else if args.length equals 2, got a missing GPA. Otherwise, I'll have 3 or more, and that's fine. I want to exit over here. I'm going to rerun my test, and that should be okay now. But anyway, that's the debugger. We'll see the debugger again, especially when we get to the web project. Even though unit tests mean that you don't need to debug as much, you still sometimes need to use the debugger in unit tests. So learning to use the debugger is something that's very valuable to do. Okay, so let's see here. It expected that, let's see, let's go back to the test. The test now is happy with this assertion, but now this assertion is underlined and saying that I expected a string containing that, but instead I had an empty string because nothing was written to standard out. That's correct. Okay. I've got some implementing to do here. I kind of want to commit this code though, but I don't want to commit a failing test. So just for the time being, I'm going to comment that out. Let's make sure everything still runs. And then we'll start implementing some stuff. Okay, everything's fine there. So let's see here. Start implementing the main method for student. Okay. So now what we want to do is create a student based on the information that's passed in, and then print its toString to standard out. Okay. So let's create ourselves a student. Equals new student. The first is the, let's see, here's the name. Which one was name? I guess that was the first argument. Ugh. Okay, so let's see here. This is args. The name is args0. The classes, for right now, they won't take any classes because I don't need it yet. The GPA is args2, 0, 1, 2, and then the gender is args1. Okay. It's not happy, and it's complaining about GPA. Oh, okay, right. It's expecting a double, but I passed in a string. Okay. How do you convert a string to a double in Java? this will be GPA string. Anybody remember off the top of your head? Cast? Oh, let's give it a try. Double. Let's see here. What does that say? Cannot cast a string to a double, so no, you can't. Let's see here. Let's see the double, capital D double. Let's see what's. Oh, parse double. Nice. Okay. Oops. This is getting too long. I'm just going to call this then GPA. Oh yeah, double constructor with string would also do it. Cones, I'm sure somewhere. Yes, exactly. Yeah. But luckily, IntelliJ was able to tell me it. I notice the student here is grayed out because it's never used. Well, let's use it for something. Let's say system.out.println student. Cool. Okay. So I think we've created the student and now we've printed it out. Let's run our test case again and see what happens. Hey, it passes. Super sweet. Let's run everything and see if it all passes too. I expected it to. Didn't really change much of anything. Great, we did. Okay, nice. Well, I guess we got all of our description correct too. Sweet. Okay, let's commit this real quick and figure out what else we need to do. I guess we need to let's see here. Create the student from the command line arguments. So, what is our next test case? I guess we should start adding some courses, right? Student can take one class. I don't know, should we go one at a time? I'm not feeling the need. Because, we implemented all that stuff in the student test and the unit test. I don't really know if we need to sort of have that same thing. So you know what? I'm going to, I'm just going to say Dave example from assignment. Let's just go all the way and see what happens. So let's see here. We invoke the main, invoke the main of student dot class with the arguments. Let's go and just get them here. Copy that, put it in here. Isn't IntelliJ awesome? It like automatically adds like the quotes and everything like that. Now, actually, this isn't exactly right because these are all, this is not one string. These are all individual strings, but actually that wasn't very helpful, was it? Because I don't really need those double quotes. Operating systems, Java, oops. So when I invoke it with all of those arguments, space. Actually, maybe it'll be easier to read if I just put all of these into args. There we go. Maybe. And then I put this into a variable named result. That's way easier to read. And then I want to say the following. I want to say, I'm just going to copy it from up here. I'm just going to copy all this stuff from up here. Dave has a GPA of 3.64 and is taking 3 classes. I'm going to put those all in a new line so it's easier to read. 3 classes, algorithms. Oh my gosh, I'm going to copy all this stuff. algorithms, comma, operating systems, comma, and Java. He says, oops, yeah, there's 2 spaces. He says this class is too much work. So if I go and run it, let's see how close we get. Fails because the number of classes isn't right. Oh, interesting. Also, we've got these backslashes there. Maybe I don't need that. No, that's right. Okay. Quotes needed around operating system. No, actually, I don't think there is. Oh, sorry, where? In this one or here? In the args of the description. In the assignment, it shows it in the output. Oh, really? No, not here. It doesn't. I think this here is the input saying that it's one argument passed in the command line. When I'm doing that, when I'm representing that in Java, this is the string that gets passed to the main, right? Because it's not actually coming from the command line. No, don't show your desk. Stay here, Mark. You're asking good questions. You're learning stuff. I'm sure like lots of people, hey, you're at least paying attention, right? Everybody else is like, falling asleep or on the TikTok or whatever it is kids do these days. So let's see here. I think what we need to do next is we need to populate the classes. So let's see here. MySpace, yeah. GeoCities. Okay, let's see, that's the GPA. So here we're going to have the classes right here. Classes, sweet. And so let's see here, what are we going to do? We're going to say for int I equals 3, right, starting with argument 3 while I is less than args.length. I plus plus, what is it saying? There you go. And now I'm going to say classes dot add args I. Manual array to collection copy. Let's see it, IntelliJ. What? Oh, we can do it. Let's see here. What is this one? Add all can be parameterized constructor. Let's see it. What? Okay, this, I don't think that's easier to read. Do you? Is it more Pythonic? I don't, that's rough. Okay. I think this is easier to read. Thanks, IntelliJ, but no thanks in this case. Sometimes the recommendations are nice, and other times they just make my eyes go crossed. Okay, so let's see here. So I just implemented that, and I made fun of IntelliJ. Hopefully it won't hold it against me. Ooh, and it passed. Sweet. Okay, wow. This is good. I'm feeling pretty good about this. What else? So I'm at one of those points where it's like, I've just implemented like the primary functionality. What else do I need to test? Add the students classes. How many times have you live coded this assignment? You can go back and it's all on YouTube many, many times. And the jokes are always the same. What if 2 classes pass in with the same name? Should we create a single class? No, that's a good question. I don't know. Or should that be an error? I don't know. That'd be a good test for the student class. I guess we could do that there. I think that would be a good thing to consider. I don't want to do that one right now though, because I think that might require some changes. And I'm looking at the time, and we've already been at this for a couple of hours. Time for a break, but I do want to finish this. There's one important thing about command line parsing is data validation, and while we validated the number of command line arguments, we should probably also validate other things about the format of the command line arguments. So let's see here. Unsupported gender prints error message. Sorry, what do we say? I had some nice, yeah, prints, yeah. Prints all unsupported gender to standard error. Oh, like GPA, yeah. Right, yep, that kind of stuff too. So let's do unsupported gender first. Kind of like this equals, okay. So oops. So name, let's see here, unsupported, and then let's just make that valid there. So we've got an otherwise, we've got all the right number of command line arguments, and then let's see here, we're just going to duplicate that to save some time. So this should have an exit code of 1, and let's see here, error is going to equal unsupported gender, and we want to say, oops, I'm just going to say, put that into a variable, call it gender. That's what I expect. And so then assert that result.get text written to standard error contains string the error. Okay, so now when I run that, what do I get? An illegal argument exception is thrown. And if we go down here, our unsupported gender exception is thrown, but what we expected is that the exit code is equal to 1 and this message was written to standard error. So what do we need to do? We need to catch this exception in our code. So let's see here. We are going to, we're going to try. And let's see here. We're going to catch an unsupported gender exception. And if this happens, we are going to say system.error.println unsupported gender. And as I recall, the message for the exception was the gender. Is that right? I think the gender string is passed in, that becomes the message, so that's cool. And then we're going to do a system.exit of 1. Let's run this again. Nice. I see an opportunity to refactor. I have the system.error.println of some message repeated over and over again. I want to put those 2 lines into a method. And I want to have this as an argument. So I'm going to call this message. And I'm going to take these 2 lines and I'm going to introduce a method for that. And so I'm going to say refactor. I'm going to find this first. I'm going to say refactor, extract method. And I'm going to call it print error message and exit. I'm going to say refactor. And it's like, hey, do you want to, oh, okay. And IntelliJ is saying, oh, listen, I saw this pattern all over the place. Do you want to replace this other thing? Yeah, it's highlighted there for missing gender. You bet I do. And I see it there too. And I see it there too. Yay, thank you, IntelliJ. I found all these places for me. And so now if I inline this thing, there you go. That's nice. It cleans up the code a little bit. And that way, if there's anything else I wanted to do, like print an error message and exit. Oh, like for instance, if I wanted to print out the usage information in that case, great. I can put it all in one place and not need to worry about duplicating it in a lot of places. Nice. Okay. So version control. Okay. And so let's see here. Print an error when the gender is not supported. That refactor feature is like wizardry. Yes, it is. And oh my gosh, It's it's one of the great things about the IDE is that it just takes care of so much of this for you. This is why that's why it's worth paying money for this. For when you go out in the real world, it's like these tools help you. They help you get your work done faster. Helps you get your work done better. It automates things. And that's why we have computers. That's why we have machines, right? Is to remove the toil of like, oh, how do I move this code to the right place, and how do I make sure everything's okay? That's what the tools are for. Student account for life. Well, as long as you want to spend your entire life being a student, yes. Seriously, if you're getting paid good money, pay it forward, pay it back. You find something valuable, pay for that software. Do the right thing. Anyway, after you graduate and go start your lucrative career. Okay. Class is going on. It's time for another break. Let's take a little longer break. Let's take 17 minutes until 8 o'clock, and we'll come back and talk about testing a little bit more. But we got some other stuff to cover tonight. I'll pause the recording. So loud. A couple questions come in over break, and before we start, I'll address them. Let's see here. Let's start at the bottom. A couple people asked about the POA. We're going to be talking about that in probably about another 20 minutes or so. So we'll get to that. Forbes asked, the student constructor throws an illegal argument exception. How does main catch it as an unsupported gender exception? Is essentially because they are both subclasses of runtime exception. Actually, I don't believe that's correct. I think if you look really closely at the constructor, these two, so if you have an empty name, it throws an illegal argument exception. If you have a GPA that's greater than 4.0, you have an illegal argument exception. If you look at the gender for string, it actually throws an unsupported gender exception. The exception that is thrown is an unsupported gender exception, and that's what the main method ends up catching. So the student constructor then calls the get gender for name or whatever that was. And that's what throws the unsupported gender exception. I suppose you could also do that under the debugger. I'm not sure. Let's use this again. Let's see our unsupported gender exception. So let's see here. Yeah, let's just run this under the debugger. Here we are at the top. We're just going to continue. And then we could look at EX, and we could say evaluate expression EX dot print stack trace. That printed out to the console, I think. Oops, what doesn't it like there? Oh, it doesn't capture it yet. Oh, right, because it probably printed out to standard out. Never mind on that. Yeah. How do you get the stack trace? Merfed. Okay, so much for debugging. Never mind. That wasn't a good example. Okay. But it's 8 o'clock. Okay, let's get back to it. So, so far in class, yeah, you've watched me code. And what have we done? We've written unit tests that validate the primary business logic, the primary functionality of the student class. We wrote integration tests that focus on the main method to make sure that our main method is doing the right thing, right? That it's parsing the command line arguments correctly, that is doing what it's supposed to. In this case, it's very simple. It creates a student and prints it to standard out. But we have automated tests for all of this. Now, you might be saying, well, this is all great, but how is this relevant to me? What does it have to do with my projects? Well, guess what? There are testing requirements for your projects. So for a long time, I struggled with how do I teach these kids to do test-driven development? How can I validate that you're writing unit tests, you're writing good unit tests? And so then I said, well, maybe it's time to requirement. So I started this, try this for the first time in the winter when I taught. It went really well. I'm going to continue it this time. So I don't think I'm going to go into too much of this, but I basically have like this little screed about, hey, unit testing is a good thing. As a matter of fact, testing is a good thing. And so much so that I want to make sure that you have I want to make sure that you have experience with it. I'm going to force you to write unit tests. And the way I'm going to do this is the following. So I use a tool called JCOCO, which stands for Java Code Coverage, to measure the amount of your source code which is exercised by the tests. So if you run the your Maven, let's see here, let's go back to student. If you run Maven with clean package, and actually, not package, clean verify, and you say maven-p greater. So -p greater runs Maven with something called a profile, which basically says, hey, I'm running it as the greater. It'll go through and it will do all its Maven stuff. It will, build the source code. It'll run the test. But when it runs the test, it runs it with code coverage turned on. And what this does is it says, hey, while your test is running, tell me what lines of code are being exercised. And at the end of it, it runs your unit tests, it runs your integration tests. And then at the end, it sort of tallies everything up and it checks whether or not you've met all the code coverage requirements. And right now, I have it set to say that at least 70% of the JVM instructions, which are kind of like the lines of code, so 70% of the instructions in your compiled code are exercised by your unit tests. And so I ran it, and it said, great, all the coverage checks have passed. I think if I go back to my phone bill and I run it, I don't have as many unit tests for this code, and I'm pretty sure this will fail. Yes, it did. Okay, so right up here, it says the code coverage checks have not been met. It said, hey, I expected 38% of the, sorry, I expected 75% of the instructions to be executed, but I only had 38%. Now, because I had implemented my student program using test-driven development, I have naturally high code coverage, and so the two are related. So, in your in your projects, as one of the test cases for your projects will be that I will run this code coverage with your unit tests. And so, by the way, you do submit your unit tests and your integration tests. And so then, if your unit tests, if your automated tests do not cover at least 75% of your code of the JVM instructions, then you'll lose some points. So if we don't have unit tests, we shouldn't have to, using TDD, support it yet. So the coverage would be higher, wouldn't it? No, because it's only the coverage of the main application code. It doesn't measure the tests themselves. They're all going to get executed. All those are going to be executed. No, it's really the test, like your phone bill and your phone call classes, that get measured. Did that answer your question, Mark? Oh, no, I see. You're saying, okay, if I haven't written the unit test, therefore I haven't written the code, and we would have a higher threshold. Yes. And so then, wow, look, if I don't write any code at all, I'm going to have like 100% test coverage. Yes, but then you'll fail all the other tests, right? The things that measure the functionality. Yeah, yeah, always thinking. Yeah, right. Is there a GUI way to view the test coverage? Yes, there is. Actually, there's two ways. That's actually, yeah, let's do the fun thing here of what you can do is, let me just go back to the student test. You can do it in IntelliJ, and IntelliJ you can, let's see here, you can say run student test with coverage. I don't use this very often, so I don't know. I don't remember exactly what it does, but it goes with stuff. Oh yeah, it gives you this little report here, and it's like, great, 83% of the methods. It says 65% of the line because it doesn't get the main in there, because it doesn't do main. But here you can see, okay, yeah, here's for students. And actually, if you go to student, it has all these green and red bars to indicate what has been covered and what hasn't been. And sure enough, you can see that, look, there's nothing for main. So maybe, I don't know, maybe if I run main IT next, or I run student IT next with coverage, it'll get the rest of that. I don't remember exactly how all that works. I don't know if it clears it out or not. Oh, there it is. Okay. Add to active suites. Yes. Did that work? Oh, wait, no tests were found. Let's try that again. Oh, sorry, yeah, did it do it? Okay, sorry, maybe it was like, do I want to display coverage areas in coverage results? Add to active suite, replace active suites, do not apply collected coverage. I want to say add to active. Okay, that didn't do what I expected it to. So I don't use it very often, so maybe I don't know exactly how to use it. You can figure that out. But what I do know how to use is the following. So we're going to get back to this in a little while. I don't know if it's tonight, it might be next time. But Maven has, one of the phases of Maven is you can build something what's called a site for your project. Actually, let me go back to student and do it there. Maven W site. So one of the cool things about Maven is that it allows you to build basically a website from your project, and it uses all the Maven conventions about taking information from the POM and seeing where all of the source code lives to build all sorts of reports about your code, about your project. And one of those reports that I have configured here is a code coverage report, and I talk about it right here. It's in this target site, Jacoco. I don't think there's a Jacoco IT anymore. I took that out and forgot to update this handout. And so it's, and actually we'll come back to this next, I guess, when we talk about documentation. So it's going off and it's doing all sorts of things. Let's see here. What's the command for that again? It's Maven, Javadoc on steroids. Yeah, it's Maven. Oh, maybe it was already there. Maybe I didn't need to create the whole site. I probably didn't. Well, there it is anywhere. So if I open up target site Jacoco and then the index.html, now I've got a nice HTML report. It says 92% of the code was covered, and you can drill into it and actually find out what wasn't. So there's something in main that it said is never, right? For some reason, it's saying that print error message and exit isn't covered, yet we know it is. So I don't really know what's up there, but that's okay. You're only, I mean, 75% is the threshold. It's not necessary to have every line of code covered, but you need to have at least 75%, so that you've demonstrated that you've written a goodly number of unit tests. And so, and actually, I'll let me do an Maven clean again, and then because I think the reports are generated without having to do the site. I think I misspoke several minutes ago. So anyway, so either as you're doing your TDD, or if you've sort of gotten to a point where it's like, oh, I should probably check to see how my code coverage is, you can run with the dash capital P greater option to here, and then, oh yeah, it exists again, so that's good. So now when I run it, yep, I get this thing again. And that will, if it passes, great. You've met all the requirements, and then you can look at this report to figure out like what code maybe you didn't miss, or sorry, maybe you missed, or maybe you've chosen not to do test-driven development. That way, you'll have to write a bunch of unit tests after the fact, and I don't think that's nearly as fun or beneficial. It's sort of like having to go back and reverse engineer test cases. That just doesn't feel good. So anyway, so oops. Yep, and so then if your unit tests do not provide, and sorry, and this is the automated test, so unit tests and integration tests. I should note that. I'll deduct up to 1 point for your grade. Any questions on that? I know I went through pretty quickly, but you can read all of my my manifesto about why testing is a good thing. Okay. So that's how to test your test your projects. Let's talk about documenting your projects. Okay. So, just like testing, being able to convey what your project, what your code does in English, in words, is very important, right? It's all about communicating and making sure that you're setting the correct expectations. And it also good documentation also makes your code easier to work with, right? So you can add more stuff to it and you can reuse things. And so there are a couple of mechanisms that we're going to use to document our code. The first is called the plan of attack, or POA. I think a number of you picked up on this because it says, hey, listen, 1 point of your grade is based on this POA. So starting with your project 1, you are required to submit a plan of attack, which is a concise paragraph or 2 about what your project does and, more importantly, how it does it. This is a little design document. It should be in text. It should be in text in the body of an email. Don't send me any attachments, please. Don't attach a PDF. Don't send me a link to a Google Doc or a Word doc or anything like that. Nope, just type it into an email and send it to me. And the reason I asked is that I've got 60 of these to get through, and I don't have time to even open up an attachment. As a matter of fact, I've written a little tool to help you go through it really quick, and that's another one of the ways that we can scale the class to accommodate so many students. So please, again, write in English. Don't write in code. And this is a design document that is meant to convey how you'll implement your project. So what are some of the classes that you're thinking about using? Maybe some of the test cases that you'll know that you'll have to be able to pass. And the POA is worth 1 point out of your project. So each project has a POA. The cones don't have a POA, but any of the phone bill, all the phone bill projects do. The POA is due 3 days or 72 hours. So this is Sunday night at 5:30 before the project. And so even if you use late days don't apply to a POA. Late days only apply to the project submission. You got to get your POA in by Sunday at 5:30. Please email it to me at my cs.pdx.edu account, and please put the letters POA in the name in the subject of the email. I use filters to put it all in the right folders, and that way I can focus on your other emails and not all these POA ones. That also means if you have an important email for me, don't put the letters POA in it because it'll get sent off someplace else. Let's see here. And of course, my hidden, the hidden goal of the POA is to get you to think, to get you to write about your project a couple days before it's due. I don't want people starting until the last minute, and so this at least forces you to think a little bit about it a couple days in advance. Hopefully you never need power of attorney. I want to be like He-Man. I have the power of attorney. Anyway, and I'm evil. Okay. So that's the plan of attack. Any questions about the plan of attack? Couple paragraphs, 3 days before it's due. Oh, do I have a POA for project 0 as an example? No, I don't. I don't have an example POA. Here again, write what you think is important to convey to me that you know what you're going to do, and I'll give you feedback. And honestly, almost everybody does fine on the POAs. It's only if you have 2 words, or if you just copy the usage information or something like that, I'll give you a low grade. Where is the guidelines for the POA written? You're looking at it. Why is it called plan of attack? It's your plan of attack of how you're going to attack this project. What is your strategy for approaching it? Okay. Javadocs in the README. So as you write code, it's important to write code that's efficient, code that is syntactically correct and easy to read. It has good names, but writing comments for your code is also important. Now, Java has a convention for documentation called Javadoc, where if you put in if you put in a certain kind of comment, one that starts with /** and ends with //. This is a documentation comment for the program element that you are that the comment precedes. So, for instance, if you put one of these things before a class declaration or a method declaration. Javadoc also supports special tags that you can put inside the comment, like @param and @return, to specify, hey, what is the description of the thing returned by this method. Here's a link that tells you all about Javadoc. As a matter of fact, let me show you some of this in practice. Let me close some of this. Now I'm kind of wishing I hadn't not generated the site, blown away that site that I generated. Let's see here. So if you say Maven, sorry, Maven Javadoc, I think this will create the Javadoc for the student. So what this does is it goes through and reads the source code. Let's take another look at our student class. How do we get rid of that? Hide coverage, there we go. So here in our class declaration, we have this comment right here, /**, this class represents a encode student. And here for our before our constructor, we have another comment. This is another one of those Javadoc comments, starts with /**, which describes the class and then has information about the, describes the constructor, and then has information about all the parameters to the constructor. So it's a param name, and it has a description of all of that, gives examples, things like that. So you can annotate your code, right? These are comments. This is not compiled by the compiler. This is source code comments that describe things like your constructor, and and methods. Things like all students say this class is too much work. So I generated some Javadoc using Maven. And now if I open, let's see here, target site Javadoc, nope, target. Oh, where'd it go? Site, oh, API docs, site API docs. And then if I open up the index.html, I get, this is not very interesting right now because it's just got one class in it. This Java documentation for my student class. And so then, notice it talks about, hey, here's the class hierarchy for the class, and it has text like this. This class represents a student. And this is taken, and this is taken directly from the source code, from the Javadoc comment for the class. And similarly, you can get information about the constructor. Here it is, all of the information about the parameters, the student's name, the class is taking. Again, this is all taken from this Javadoc comment. And what's really cool is then you can link this API documentation off to other API documentation. So, I can say, oh yeah, this thing takes an array list. You can click on this. It brings you off to the standard Oracle docs. Oops, someone just showed up again, for array list. And so then it allows you to navigate in between, between various sources of API documentation for Java code. And the nice thing about Maven is that because you're following all the Maven conventions, the Javadoc plugin does all the work for you. So all you need to say is, hey, create me the Javadoc, and poof, there it all is. And so then for this class, Javadoc is a way that you can convey what it is that your code's doing. But if you're writing a library or a code that's going to be reused by somebody else, you can go and publish the Javadoc, off to your website or wherever, so that people can find out how to use the software that you're building for them. Oh, and notice also you can navigate to like the superclass, and then this goes off to my website that has information all about this code. So just the same way that you're reusing my code, now you can also reuse my Javadocs, and then this hooks everything together. And so I like Javadoc so much that it's part of your grade. So I have one of the test cases that I put your code through is that I generate some API documentation for it, and I want to make sure that there is a comment for every class and method that you write. So please, make use of the Javadoc comments and the Javadoc tags to make sure that anybody who looks at your source code or generates Javadoc from your source code knows what's up with it. Now, somebody asked during office hours, do you look at our code to make sure that it follows in coding conventions? No, I don't. And nor have I gotten to the point yet where I want to enforce coding conventions. I don't think I'm quite ready for that yet, and I don't know if I'm ever going to be ready. I don't think it's necessarily, that important. But I do recommend that you look at this link here, which is Google's conventions for writing Java code. It's important that you learn how to write sort of idiomatic Java code, so that other people that are used to seeing sort of the way Java code is structured will look at your code and be familiar with it. It'll feel familiar to them, and they'll be able to approach it and use it more easily. Okay, the final piece of documentation. So we've had the plan of attack before it's due. We have Javadoc as part of what you submit. Another thing that your programs do is they have a README switch. And so when the -README is present, all your program should do is print the README and then exit. It shouldn't do any command line validation. It shouldn't perform any operations. The whole idea is that what README does is it prints a brief, concise, and also nicely formatted text description of what your project does. Well, more than just the command line usage, but maybe like a sentence or two. And again, this is all part of conveying what it is that your program does and how the user interacts with it. This is out of date. This is wrong. For many years, I said, hard code your README in. And then I'm like, why am I making people do that? That's kind of silly. So in the phone bill, I'm pretty, no, where is it? And there's an example in the test. That's what it is. I think it's the, which test is it? Shoot. Was it phone bill test? Phone call test, maybe? Sorry, let me see if I can find README. Oh, project 1 test, right. So there is included in here a file called readme.txt in the phone bill. And this lives off in the source main resources directory. And so then this is a file that you can submit it with your project, and this will contain your README. And I don't make things too easy for you, but I've given you a little test here that makes sure that it can be read as a resource, and then you can do stuff with it, and then you can print it out in your real program. And so I encourage you to leverage the code of this test in your main code to read the README file and then write it back out again to standard out. It's also a good opportunity for you to start using some of those Java I/O classes that will be focusing in on project 2. You can hard code if you want, but you can also read it from a file like it is here. Okay. Any questions on this required documentation and communication for your projects? Nope. Okay. So you've gone through and you've written tests for your code, and you've written your code, and you've written documentation for it. Now, how do you submit it? How do you get it to me so that I can grade it? So many years ago, I wanted to learn about the Java Mail API that sends email using Java code. So I'm like, well, what would be an interesting use case for this? Oh, hey, I know. How about I have the students email their source code to me, and so I can work with it. Oh yeah, Luke points out that you can use IntelliJ to generate Javadocs, but I'll be using Maven. So I wrote a program that does exactly that, and it's called edu pdx cs410j grader.submit. So this is the submit program. And what it does is it takes some information from the command line that you enter in terms of like what project that you're submitting and what the files are, and it takes all the files and it gloms it into a jar file, or maybe it's a zip, I can't remember, and emails it off to the TA. And then I've got a bunch of automation that then takes all those emails, extracts the submissions, and that's what I use for grading. Again, this is an important part to making this class scale because I'm able to automate this drudgery of getting all of your assignments. This is why I don't use T2L to submit all of this stuff. I don't want to be spending my time extracting all that stuff. I don't want the graders spending their time extracting all that stuff. Instead, I wrote some tools to do it for me. So here's what you need to do. On one of the PSU Linux machines, so this is something you can't do this, you can't send emails, do it from the PSU machines. After you've run all your unit tests, make sure everything's fine, this is how you go and submit your code. You run this command here. You run the Java virtual machine, you put migrator jar on the class path, and then you run the submit program. And the submit program has 5 required arguments. The project is being submitted, like project 1, project 2. Your name, your Unix login ID. This needs to match the login ID that you use to create your project. It needs to be in your package name. Then your email address, and then also the directory that contains all of your source code. Then this is going to be the SRC directory. And what this will do is that it'll go and find all of the Java files, all the text files. We're not doing XML, and we'll zip all those up into a file, attach it to an email, and send it off to the grader's account. And it's all the Java source code. So it's your your source main, your source test, and then your source IT. All that should be submitted. So here's an example of doing that. Let's say I had all my code in a project 1 directory. Well, this would probably be inside my GitHub repository, but you get the drift. And then you run the program. Recall that / is the line continuation character in Unix. And so you'd start with project 1. You'd give your name, your Unix ID, your email address, and you can also have an optional comment like, hey, this is something that, this is project 1, or it's like, oh, hey, there's some bugs in it, or hey, here's my resubmission, stuff like that. Nice little note for the grader. And then the directory that that contains all your source code. You'll get a little confirmation. You'll print out all the files that are going to be submitted. You can say, oh yeah, I really want to submit it. When you do that, that's when it goes off, and we'll send it to the grader. Sometimes that can take a minute or two as the zip file is put together and is sent to the mail server. You should receive a receipt that saying which files were submitted, and that's it. Let's see here. A couple of notes. The submit program only allows .java, .xml, and .txt files that are in the source directory. You don't submit your POM, you don't submit class files, nothing in your target directory. I just want the source code. It's essential that your source code is in the right directory structure. If you've used the create scripts, this should be the case anyway, but it's an edu pdx.ts410j or a login ID. Feels like Dave's version of git clone. Yeah, I probably at some point I need to evolve this to use git, but I don't know if everybody's ready to start using tags and branches and everything like that in git. So I think this is probably a little easier. Let's see here. This hasn't been a problem in many years, but you're not allowed to submit any of my code back to me. Some people would change the abstract classes and stuff. It's like, nope, I'm not going to accept any of that. And so the program will reject that. Please, please, please make sure that your code compiles, that your tests run before you submit it. It makes me and the graders grumpy to get a submission that doesn't compile, or one that sort of falls over right away because the tests don't pass. Make sure to run a Maven clean verify before you submit, and your code should be fine. Please submit all of the files required for your project, and do this in one invocation of the submit program, one email. I'm not going to take the time to say, oh, wait, these 3 files come over here, and those 5 files. Nope. With so many of you, I ain't got time for that. I'm not paying the graders to do all of that. I want them to put their time into giving you a quality assessment of your programs. It's okay to submit multiple times before the due date. No problem there. Although, please remember that, for each submission, it needs to be extracted and things like that. So, don't make like a change and then submit and another change and then submit. Be judicious about your use of the submit program. Another advantage for me of the submit program is it has the timestamp on it, so I know when things are submitted, and this is how I determine which projects are late. And so then, no late work will be accepted subject to the late days, et cetera, et cetera. That's what we have there. If you're having problems submitting, which really hasn't happened recently, but there is a dash verbose option. There's also a dash save jar, which will save off the jar file with all of the, with all the submission material. And so then if you need to debug it, or if you and I are trying to work something out, there are some options for you there. And so that's how you submit. Any questions on that? Yeah, lots of stuff. So you'll use the submit program for all of the code that you submit. So the projects and the cones all get submitted with that. Okay, one more handout to look at, and that's project 2. So hopefully all of you have started project 1 by now. You've got the POA for that due on Sunday, so can't be started too it can be started too late. Tonight, I'm going to assign project 2. Project 2 is due 2 weeks from tonight on July 15th. And this is the reality of the course. You've got multiple projects open at the same time. As a matter of fact, right now you have 3, right? You have project 1, you have project 2, and you have the cones. And you've got the quizzes. So lots of work all happening at the same time. This is how we can, is how we can provide so much content in an 8-week course. It's, it's not serial, it's parallel. Oh, question from Mark. Cones project does not have a POA, but do we need Javadoc? No, you don't. No, you don't need to write Javadoc for the cones. That's a good question. I'm not going to test the Javadoc on the cones. I will on all of like the code that you write, the application that you develop, which is the phone bill. So this is the second part of the phone bill assignment. Now, as a couple of you pointed out, project 1 doesn't do very much, right? It reads the command line, it creates a phone call, adds it to a phone bill, and prints out the toString of the phone call. Not very interesting. Oh yeah, submit the cones using the same method as the projects. Yes, you do. So yeah, the projects are used for the cones. Sorry, the submit program is used for the cones and the projects. In project 2, you'll be extending your project 1 to really have to do something more interesting. And what that is writing the contents of your phone bill to a text file. So in project 1, there's no persistence. And so as a result, yeah, you never have more than one phone call in a phone bill. And that's kind of silly. That's true. And that's fine for the first week of class. Now we're in week 2. You're writing to a file. So, the intent of this project is that it gives you experience working with the Java I/O APIs and doing things like, reading in files and dealing with exceptions. And so then there's some code that you need to implement. This is all code that will be implemented in your package. So there's a class called TextDumper, which implements the phone bill dumper. The phone bill dumper is an interface that has one method, dump, and it takes an abstract phone bill. And the whole idea is that it takes that phone bill and then writes it to some, destination, and it'll be a text file in this case. And it writes the entire contents of the phone bill. So the phone bill, the owner of the phone bill, what's it called? And the customer and all of its calls writes a text representation of those out to a text file. The format of the text file is completely up to you. It can be whatever text-based format you want. Please don't have it be binary. Text-based format, and it needs to be and your program that needs to be able to read it in again. That's in the text parser. So yes, so please not binary, but any text file any text format that you want. So there's a text dumper that takes a phone bill and writes it out to a file. There's also a text parser that reads in a text file and from it creates a phone bill with that information. Those classes are used by a project 2 who has a class that has a main method that will optionally read a phone bill from the contents of a text file, create a new phone call who that is specified on the command line, just like in project 1, adds the phone call to the phone bill, and then writes it back out to a text file if the -text file option is specified. And so here's the command line interface. It has the same 5 required arguments as project 1, but now there's a new option, -text file. And so this is the location of the file to which the phone bill should be read and write. Now, please note, if the text file doesn't exist yet, this is okay. Don't try to read from an empty text file, but please don't issue an error message either. Otherwise, your program can't get off the ground. So the first time you run your program with a -text file, the file won't exist yet. That's cool. Just create a new empty phone bill, add the new phone call to it, and then write it out to the text file. Let's see here, and the text format, the format for the dates and times is the same as the last, as project 1. Oh, note, please, you don't need to create a new Maven project. For projects 1, 2, and 1, 2, 3, and 4. No, sorry, 1, 2, and 3. It's all from the same. You just keep evolving your source code. When we get to project 4, when we get to the REST project, you'll be creating a new Maven project because you're going to be doing a lot more stuff. So your question came in from Evan. So these new classes will exist in the same direction as the project 1. Yes, it did. Good, and you answered your question. Yay. Oh, and for those of you who are fans of generics, there's another parameterized type there in the dump method. So another opportunity to like explore generics and how they're used here. So note on error handling, just like project 1, you should have graceful error handling. So a user-friendly error message, and here's some examples of things that you should report on. So if your command line is incorrect, something's missing or there's extra stuff, date and time formats are incorrect. If you can't read in the text file, you should issue an error message. And if the customer name that's given on the command line is different than the one found in the text file. So basically, the whole idea of the text file is that it has a phone book for a given customer. And if the command line says the customer has one name, but the file has a different name, that should be considered an error. Let's see here. Question from Mark. So projects 2 and 3 are effectively just later commits to the same Git repo. Yes, that's what I recommend that you do. If you wanted to use branching or something like that, fine. But having it all in the same Git repo usually works fine for students. Okay. Hey, questions on project 2? Due 2 weeks from tonight. Okay. There are a couple of bonus topics that I want to plow through. I think the stuff that'll be interesting. Sorry, what time is the POA due? Sunday night at 5:30, so 72 hours before the assignment. So I mentioned Javadocs. I mentioned code coverage. And I mentioned, then I said there was this thing called Maven site. So I'm going to create the site again. So, oops, Maven W. I'm going to do this again for student. So the whole idea behind Maven is that Maven provides a set of conventions for your Java project, for the layout of the source code, right? Certain name directories. And because there are these conventions, there are all of these plugins that you can develop that have been developed for Maven to do all sorts of things. Now we've seen plugins for compiling the code and building jar files. There's plugins that run the unit tests and everything like that. But there's also this whole suite of plugins that generate reports about your project. And it gets the information for these reports from a number of sources. We saw Javadoc, right? So that is, those are tools that will look at your source code and from it extract API documentation. We saw Jacoco, how after running your unit tests and integration tests with code coverage, it takes all that analysis and generates these nice reports for you. But there's other sources of information, such as information in your POM and just even like the source code itself. If you run Maven's site, I have the projects configured to run all sorts of analysis on your source code and then generate reports. So if we then open target site index.html, this is the Maven site for the student project. And over here, let's see here, it knows it's called student. It has this little description here, a simple student program to get you started with Java. This all comes from the pom.xml file. So let me open that up real quick. So if you really dive into the POM, you'll see things like, hey, there's the name, student project's got a description. Well, and it's got a URL. All of this is used here. I guess there's where the URL is. And then, it's like, hey, here's the name of the project. Here's the description, things like that. And then, from the information in the Maven project, it creates a bunch of reports. So here's a report about all of the dependencies that the project has. This is all the other software that it depends on to do its work. So it has things like, a link off to my examples jar, which contains the human class, things like that. Here's links off to JUnit and to Hamcrest. And these projects all have home pages that are mentioned in the POM files for JUnit and for Hamcrest. So this is really what the POM is all about. It's a description of the project, and the projects can see each other's POMs. They can reference each other's POMs to generate this kind of stuff. It tells you what kind of license it is, et cetera, et cetera. And then it goes through and says all the transitive dependencies. So here's are all the things, all the dependencies that our dependencies have. And so you can see, things just like, hey, here's all the stuff that's that is included here. Things, all the projects that are needed, all the libraries that are needed, and it tells you, hey, what licenses are involved. Now, I'm not going to go into too much detail here, but I think those of you who have maybe taken like the software ethics course, licensing is very important. And certainly, and licenses have, they're legal documents. And you get the wrong license in your code, and all of a sudden, oh, look, all of your code must be open source. Otherwise, someone's going to sue you. So you need to be careful about what third-party libraries you're using to really understand the ramifications of using them. So here's a report. I mean, it gives you a whole tree of dependencies. And a summary of all the licenses. All sorts of great stuff like that. What else do we have? It's sort of general information about it. I have links off in my POM to, let's see here, where's the issues section? Oops. Oh, maybe this is inherited from something else. Yeah, it probably is inherited from the parent POM. Let's see here, you have information about, the licenses for this project. Yep, okay, this is all inherited from the parent POM. Not so interesting here. But what is interesting is the project reports. So let's go start at the top. There is there's a tool called Spot Bugs, which this is not the most interesting example here, but the whole idea is that it looks at your source code and finds common sources of error. Let me go, let's see here, nope, I won't find it. Let me go open up the Maven site for github.com. No, that's not what I want. I want David, github.io. Here we go. Oops. Yeah, that's what I want. I'll show you how to do this if we have time. It's getting late. But what I've done is, so this isn't for like my summer 2020 code. This is for like just all my code in general. I've created a Maven site and I've deployed it off to github.io. And so now, here is all this stuff out on the internet. And so I can go and look for, I'll find the family tree application. Is there spot bugs for this? Yes. Okay. So spot bugs goes through and looks at all of your code and looks for some things that like maybe aren't so good. So let's see here. Here is it's kind of complaining about something where it's like, okay, this is a I don't know, unrelated class and interface. And so if you click on it, it's like, wait, what is this telling me? Why is this a problem? And so then it goes to oh, it's got so it's some code that uses the equals method to compare a class and an interface or two objects that aren't related. So it's like, wait, there's no class hierarchy relationship here. Why are you comparing these two objects? And what this does is it sort of helps you find this database of potential bugs has been developed over years and years and years from actual Java developers that have been like, wow, there was something really subtle about something that I did, and they wrote a tool to detect these subtleties or detect these potential errors to give you, to then say, hey, maybe you should go check this out, or hey, maybe you've got a bug here. How about you go, how about you go fix it? So like this one, what is it saying? This method invokes, it calls new integer. So you should use integer.valueof instead. So it's like, hey, you got some smelly code right here. And actually, it even gives you a link off to, let's see here, line 37. Right, so it's like, hey, don't use new integer.id. You should use integer.valueof int instead. Okay, that's neat. That's nice. And the reason I'm pointing out this, though, is that all this comes basically for free when you use Maven. You configure it the right way, and it does all this analysis for you. You can also get pretty versions of your source code that you can easily link off to and send people links to, which is kind of nice. Reports. You can get links off to your Javadocs. I also have Javadoc for the test. You can also get links off to your code coverage here. And then as you can also get reports on your unit tests, your integration tests. That's what Surefire is. Surefire is the Maven plugin that runs the unit tests. You can say, yep, everything passed. Here's how long things took. And you can, if there were failures, it would have like little red triangles there. And you can, I guess you can't drill down into them. I thought you could. So anyway, so some really cool stuff here. I guess there is a check style, which will tell you if you've got it says, hey, there's okay. So it's got some recommendations on your code. So let's see here. Here's details. Right. So it's looking at student.java, and boy, it's complaining about all sorts of stuff. Look, this line is longer than 80 characters, and hey, this it says missing a Javadoc comment, right? So here's some code. Oh, okay. It's saying that this private field should have some Javadoc comment. I don't put a lot of stock into this. And really, if this kind of thing is used for real, what you do is you tune it to just complain about the things that you really care about. The fact that it's got 84 characters instead of 80 for for a line length, really in this day and age, that's just a problem. But things like this, like the gender, it's probably a gender variable or something, or a gender parameter, hides a field. Yeah. So it's saying, hey, listen, you probably shouldn't have a parameter that's the same name as a field. I beg to differ, but it's saying, hey, this is something that might cause you some problems down the road because it's confusing. So anyway, but all this neat stuff that you can very easily, all these analyses can be very easily done against your source code. Oops. Anyway, and that's all with Maven site. One other thing I wanted to finish up with. Where's my source code? Okay. So, oh wait, how much of the Javadoc stuff can be accessed through the IDE? Yeah, what is it? What is it? Is it Command F1? There used to be Control F1? There used to be a way to get the Javadocs for these things. I don't remember how it was. Is it View? Actually, wait a second. Let's just look. Generate Javadoc. Oh, Javadoc preferences, smart keys. Smart keys. Where is it? Here we go. Automatically. Oh, okay. Insert closing tag. That's not really what I wanted. If the question, Andrew, is like, hey, can I see the Javadocs from the IDE? I think the answer is yes. I don't remember what the shortcut is though. Jump to source. Honestly, I mean, these days I just like to just look at the source code. Written by Josh Block. Okay, and I can find it that way. And you know, maybe I'm old school, but I'm just very used to having a browser with the API documentation up in it anyway. Okay. Let's see here. Where was I going? Oh yeah, one more thing I wanted to show you. So there was a question earlier about, you know, when do you run Maven? You're working in your IDE, you know, and you're doing most of your work there. You're writing your code, you're running your tests, you're getting things to pass, you're making progress. When do you go back and run Maven? And I said, well, you know, when you think about it, or, you know, make sure to do it, you know, often enough. I didn't have a really good answer. But what if you had someone to run Maven in the background for you? And that's the whole idea of continuous integration. So one of the nice things about having an automated build and having code that is in version control is that you can have something called a continuous integration server that does the following. It just sits there, waits for code to be checked in, and when code is checked in, it gets a checkout of that code, builds everything from scratch, runs all your tests, and tells you whether or not things are still passing. And this is really great because it'll give you early feedback when you've broken something. So let's say, you know, you've written some code, you thought you thought you'd run all the tests, thought everything was okay, so you go ahead and check it in. Oops, maybe you forgot something, or maybe you broke something, or maybe there's a whole bunch of tests that only get run, you know, that you don't want to run every time. But you know what? We've got a machine running in the background that will verify all that for you. And that's what continuous integration is all about. So there's this site called Travis-CI, so Travis Continuous Integration, that hosts for free that hosts this continuous integration server, and you configure it. Well, you figure it in a couple ways. First of all, you create an account, and you can link your account to GitHub, which is what I've done. And then you give it permission to view all of your GitHub repositories. And then what you can do is you can create these essential build jobs from it, and you can configure those build jobs in a file called .travis.yaml. Oh, interesting. And I still have it set to JDK 11. I should probably use something newer. But anyway, here's what you do. You say, hey, listen, I've got a Java project right here. I want to build it with OpenJDK 11. The sudo default says you don't need to have this. And what I want you to do, I want you to run Maven, the Maven wrapper verify. And so what it does is, and I've configured it to use GitHub. So when I check code into GitHub, it will automatically get the latest code and run Maven W verify on it. And so now, is that this one right here? Oh, well, interesting. I thought it automatically found that repository, but maybe it didn't. Nope, okay. Well, cool then. I will make a new repository. Let's see here, I will add one. And let's see here. I think I need to refresh. I changed this the last time I saw it. So your filter repositories, summer 2020. Oh, there it is. Great. I'll enable it. And let's see here. Do I need to have anything in the settings? Oh, it's just saying, hey, when I do a pull request, if you're familiar with pull requests in GitHub, do I want to build the code in the pull request? The answer is yes. That's always a good thing. Okay, so let's see here. Let's just go and do it. Okay, and so then let's see, it says no builds for this repository. So maybe I need to push some code to build it? I don't know. Let's write a test real quick for student IT. Let's well, actually no, let's just try building it with Java 14. That'll be a nice quick change. Let's see here. Build Travis with Java 14. And so I'm going to commit it and then push it up. Why did I do that in 2 operations? That was dumb. VCS git push. I'm going to push that to GitHub. Okay. And then when I do that, so if I go back to this, hopefully, branches. Oh, there it is. Good. Okay. So it just said, hey, you check something into to the repository, and now it is going off and doing its thing. It is building it. So then let's follow the log here. So this is actually pretty cool what it does. It's got this, server farm. I don't even know what you call it that anymore. It's got a bunch of machines that are running in the cloud, and it goes off and provisions the machine and configures it to have the software. I've told it to put OpenJDK, but it supports all sorts of different, build environments and programming languages and stuff. And it goes off and installs the OpenJDK 14, like I told it to. And now it goes and gets the source code, and now it builds the source code. Now it's downloading all of the artifacts from Maven, and so then this takes a while. But we're just watching it scroll by. But then it builds the project, and so then it'll compile the source code. It will run all of the tests, and if anything fails, it will send me an email saying, "Hey, wait a second, your code, the code that you checked in." Fails the unit tests, or fails one of your tests, or doesn't build, or whatever, and so please fix it. Something came in chat. Did you have to manually trigger the first build? Not so much manually trigger. I had to check in a change in order for it to detect that initial build. So yes. Oh, and then you can add a build passing badge to your README. Exactly. And actually, I can do that. Well, actually, there already is one. I might need to update it though. So let's look in the README for the top level. And yeah, why do you default to that? Just give me the raw show editor only. There we go. Oh yeah, there it is. So yeah, so if you change this to so mine is David Whitlock, and then that's the badge right there, that SVG. You should do that. And actually, are there other places? Your GitHub. Where else do I need to do? Okay, this is just examples and stuff. Yep. So anyway, let's see how that build is doing. Hey, it was successful. Great. So now if I'm going to change this. So I'm going to say update the Travis badge to point to my job. So now I'm going to push that up to GitHub. Now, when I go view this on GitHub, I'm going to reload this, scroll down here, and sure enough, as the build is passing, and when oh, wait a second, the link is still your GitHub ID. I need to fix that too. Oops. Come on. Oh. This is the build that's passing, and when I click on the link, it brings me back to Travis. Oh, and by the way, a new job kicked off because I pushed a change. So this is the cool thing, right? You've got Travis running in the background, giving you continuous feedback on the state of your code. And so this is where you really get that return on the investment of having an automated build and having your code in GitHub and using these standard tools like Maven and GitHub that that sites like Travis CI can take advantage of. Right? Isn't this neat? And so then you get like a clean room validation that all of your code will compile. So that's a little bonus. This is not something that you need to do for this course, but if you maybe in your capstone or if you're working on, maybe it's a open source project. This makes it easy and valuable to have all these automated tests because you can again get that feedback, get that validation. Oh, okay. Ronnie says you can trigger a build for more options. Great. Thank you. I didn't know that. Okay. Any more questions about Travis, about continuous integration? Nope. Okay. That's cool. Well, another long night after 9 o'clock, and I think that's enough. So that's everything on the agenda. So just to review what we covered tonight, we wrote some more tests. We wrote some unit tests. We learned about integration tests. Then we learned about some of the requirements for the projects. We got code coverage requirements, at least 75%. And then we learned about how to document the comments. So you've got the POA that's due on Sunday nights. You have required API documentation in Javadocs. And then you have the -README option that describes what it is that your program does. We saw how to submit our files using the submit program that must be executed from the PSU machines. And early on, we saw how to use GitHub to move code from your local development machine off to the PSU machine, so you can make sure that all your code, it moves completely over there. And by running the Maven build, you can be confident that everything runs as expected. We saw project 2, learned about that. It's the next phase of your phone bill. You'll be writing to text files, writing and reading to text files. And then we got a little bonus looking at the Maven site, what that's all about, and looking at the and Travis CI for doing continuous integration. So I want to give a little preview for next week. So next week, we start our odyssey into pair and mob programming. So what we'll be doing is called a code kata. It's a little programming exercise. Just as a preview for those of you who are trying to arrange your schedule, for the pair, there are 2 opportunities to pair, and that's in weeks 3 and 4. There are 2 opportunities to mob, and that's in weeks 5 and 6. Wait, is that right? Yes. Yep, weeks 5 and 6. Each student must attend. Sorry, each student is required to attend one of the pair programming sessions and one of the mob programming sessions. So please plan to be in class either next week or the week after that, and similarly for the mobs. Okay. Oh, I'm glad you like the end of the class summary. Good deal. I feel like this should be a required class. Well, I don't think I could teach every term and still get my job done. How will you know if we attend? Yes, you can do both. I will know that you attended based on a couple of things: your contributions to a shared GitHub repository, and then also you have a quiz due on that. You have a reflection, and so then sure, I suppose you could make up something about what your pair programming experience would like, but that would be tough to do. So we're gonna give it a try next week. We also have, I don't know how many breakout rooms we can have. I hope we have enough breakout rooms, but we'll figure it out. I am confident that we can pull off pair programming remotely. And yes, you can. And again, feel free to you can attend both sessions, but I do want you to take advantage of that and pair program with someone. Okay. So, any final thoughts? Any final questions before we for the break for the week? The pair mob programming sessions are during class time. So next week I'm not going to do as much lecturing, as much stuff. Should we plan on attending both classes, or is it super optional? You only have to attend one. I will tell you this, though. So next week is mainly pairing. I'll, of course, talk about Project 3 and stuff like that. The week of July 4th, though, I'll be introducing the Project 4, and that's different. You'll be creating a new Maven project. You'll be doing client-server programming, and I'm going to talk more about that. So here again, you can watch the recording because, hey, come on, it's July, right? People are going, well, I don't know, no one's going on vacation this year. Next week, there won't be as much new content as there will be on the 15th. I'll say that much. Okay. Good deal. Okay. Well, hey, thanks for another long week. Have a good week. Please, as you have questions, post them in Slack. That's probably the best way to get a hold of me quickly. And I will see you, hope to see all of you, or at least many of you, next week. Bye now.